time no see.
Just hearing about Watson and their keynote.
Oh yeah, was it?
It's good.
I've been there only shortly because I started to prepare my talk.
Oh, it's on the TV. Just checking out what my room is for later. When did you arrive?
Yesterday. So I missed the speaker's dinner.
Yeah.
We go back at the hotel like 10,
Yeah. Okay.
and then it's like I either go to sleep or I go to the dinner.
No, I think. Well, I don't know. We left there at like 9:40.
Oh really?
But a lot of people are still there. You know how it is in Portugal.
Huh.
Stay there, right?
Yeah, that's true. I've been here like 4 times at this conference.
This is my first time.
Yeah, it's really cool. For you, it's far, right? Or you've been to the UK before?
No, no, I came straight from Atlanta.
Nice.
Cool. Anyway, good. Have a good talk.
Yeah, I'll see you later. Yes. I can hear myself. I think so. Some crackle. Test. Test. 1, 2, 3. I think it works. Oh, test. 1, 2, 3. Test. Test. 1, 2, 3. That's better. We can start? Okay. Great. So the first talk on this AI track will be about going beyond prompt engineering. So I'm going to assume most of you have tried prompt engineering or code assistance or ChatGPT or any sort of AI that you might have seen infused in some products you might be using here and there. So I'm not going to really focus on prompt engineering. I'm going to show how you can go beyond by building your own AI applications. First of all, I'm happy to be back. It's actually my 5th time here. So my first talk was in 2019. Then I did a remote one. And then for the last 2 years, I've been doing some GraphQL talks. So maybe some of you saw my talks. That would be really fun because there will be some GraphQL at the end. But yeah, really happy to be back at this great conference and great to see that it keeps growing and people keep coming to Coimbra even though it might not be the place where you live. So this year will be my first sort of non-GraphQL talk because all of these have been mostly GraphQL and this one will only have a little bit of GraphQL in there. So over the past few years, a lot has changed in how we use AI in software development. Maybe you've been starting to play with AI like 10 years ago or 20 years ago already. Or maybe you just started like last year or this year when you found out there are tools like ChatGPT. So to think back, in 2016 or 2015, I don't really remember, I was doing a machine learning course. And in this machine learning course, it was like a 3-day course aimed at like people who already knew some Python but didn't really were really proficient in Python. So I started to do this AI course, and what we learned was how to build your own machine learning model. And maybe you've ever tried to build a machine learning model. Today, actually, you don't really need to build one anymore, but more about that later. But in order to build a machine learning model, you need some code, like in Python or Java or JavaScript. It doesn't really matter today. But in order to understand what the code is doing, you need to know about computer science, statistics, mathematics, and also machine learning. And then in 3 days' time, you can build a machine learning model that's able to distinguish between Chihuahua dogs and muffins. So that was AI I was doing in 2016 because the company I worked at, they wanted me to build a recommendation engine for like TV shows or whatever. And in 2016, when you wanted to build a model like this, you always build a model for a specific purpose. So you're building a model to distinguish between Chihuahuas or muffins, or a model to recommend TV shows, or a model to find people similar to yourself if you're building a social media thing. So AI in 2016 was really focused on specific tasks. You're building a model to do something specific. And then if we look at today or 2 years ago, AI has moved away from being very specific to being very generic. So these large language models, they're all multi-purpose. They're focused on a broad scope of things. With an LLM, you can do anything from asking questions about math to figuring out who's your favorite actor, or whenever, I don't know, something weird like who's the wife of the president of France. These are all things AI can help you with, even though the model isn't specifically trained to do a specific task. And if you look at LLMs and you want to make LLMs smarter or better for your use case, you need to do some tweaking. And there are some things you can do, like prompt engineering, which you maybe have tried. And then there's other things like making AI context aware. So in most part of this talk will be focused on making AI context aware, on helping it to become better at your specific task. So as we moved away from models specifically trained to do a task, we now have models that are trained to do everything. And as developers, we need to find ways to make these models built for everything work better for our very specific use case. So it's a bit of a upside down from where we started. And on the right, you can see also a code assistant. So let's look at code assistants first as well, because this is something I'm using almost every day. Is any one of you using a code assistant? Oh, nice. A lot of you are. That's good to see. So I use code assistants almost every day, and the code I'll be showing you today was also partly written by code assistants, or at least suggested by code assistants. I use it a lot to generate mock data. So whenever you start to build something, you probably don't want to connect to APIs already or connect to a database. You just need a bit of JSON or whatever type of mock data you're using. You can also use it to optimize existing code. I don't really do this because I usually have a generate code and then I redirect the code. And also for stuff like debugging. Sometimes you can see an issue, something doesn't work, and you can just ask a question for a specific code block to help, for example, GitHub Copilot help you. So I use it a lot to generate mock data in situations like this, or to write tests. And in case you wonder, and this will also be continued in the rest of the talk, in order to generate code for you, GitHub Copilot, for example, it won't look at your entire code base because it's too much information. It will only look at the open tab. So if you're writing a test, for example, you can import the function, and then it will be able to retrace its steps to that specific file. But even better will be to have a separate tab open in which you have this file opened. Is this dark code? Is it visible from the back? It is? Okay, that's good. So I use it to help me generate code, to write tests, and mostly these things. So one important thing to keep in mind when using GitHub Copilot or other code assistants, keep a tab open with the code you wanted to base its responses on, because it needs context in order to have better answers to your question. Because it's trained on a lot of code bases, but not specifically the code you just wrote. So make sure to either import or have this tab open. So we're trying to make LLMs context aware. And in this talk, I'll be showing you how you can build things like this yourself. So a little bit about myself. My name is Roy. I used to work for a nice GraphQL startup called StepSim. We were acquired by IBM. So I've been working there now for a little over a year. This was me at the GraphQL Conf last September. So maybe you'll know where my interesting GraphQL comes from. I wrote some books and I also put videos on YouTube. So if you want to know more about what I do or technologies I use, feel free to find me there. If you didn't visit Jnation before, then also go to YouTube to their channel because they actually post all the videos there. So if you're trying to figure out what people spoke about last year or the year before, you can find all of that on YouTube. So that's a good thing to know. I'm also more than happy to connect with you on social media or whenever you find me in the hallways of this conference. So AI has changed how developers write code. I already saw that a lot of you are using code assistants, so it probably also changed the way you write code. You're using code assistant, you're using chat assistants, you get help day to day. Maybe otherwise you would have went to Stack Overflow or just Googled something. You ended up on some weird forum where people were discussing this, specifically an issue you're facing like 5 years ago. So AI has already changed how we write code, but do you actually know what's happening under the covers? Does some of you try to state that they know what's happening whenever you ask a question to an LLM? Maybe some of you feel confident to say that they know. That's good. Someone thinks they know. Someone thinks they might know. Well, probably all of you know because you know how to write code, so you can probably imagine there is some back and forth between a backend and then there would be a backend that does something. But yeah, later let's see if you actually know. So let's look at a typical code assistant or a chat assistant flow. So you have a question which you will type, it will end up at the LLM and you will get an answer. And in between, a lot of things are happening or could be happening or are supposed to be happening. I mean, if you're writing code, quite often what you want the code to do doesn't actually is what the code ends up doing. It's the same when you're building AI applications. So if you have a question and an answer, we like to call this like a QA thing. There is always some code in the middle, and this code in the middle will determine what's going on. There could be very simple code in the middle, maybe it's just an API call to an LLM, or there could be really complicated code in the middle where it might do multiple calls to LLMs, it might do calls to different LLMs, it might goes to a database or goes to different sets of APIs and then returning back to the original code that you have in between. So in between your question and your answer, a lot of things can happen, but it can also be really simple. And what happens in between often ends up being still the same things we did in 2016 when building AI. You need computer science, statistics, mathematics, and machine learning. But the good thing about living today is that you don't actually need to know all these things because there is also APIs and wrappers and SDKs to interact with models, so you don't have to build them yourselves. But it always is useful to know more about what's going on under the covers. I always like to say there's two types of developers that play with new technology. You have developers that use it and then it works and then they say, great, it works. And then you have developers that before they actually try it, they will go to the documentation, they will look at the code, they will look at tests, and then they actually implement it. They make it work, and then they try to be the best at that specific technology. I'd say I'm somewhere in between. So I always try to use something. If it works, it works. I don't really care about it anymore. As soon as it starts breaking, I'm going to find out why it breaks and how it actually works. So if you want to deep dive into the covers, you actually need to know mathematics, computer science, statistics. But you don't have to. That's one of the great things of being a developer today. So you don't have to be a data scientist in order to work with LLMs, in order to build AI applications. I think it's some sort of misconception that you need to be a data scientist or a data engineer in order to understand what LLMs do and how you use them, because it's just code in the end. So there's a term that the internet likes to call AI engineers. These are developers that work with AI. They implement code based on AI. They implement code around AI, but they don't necessarily build the AI model. So there's a huge distinction between building models and building implementations of LLMs, AI, everything around a model. And the internet likes to call this AI engineer. Maybe if you go to LinkedIn or Twitter or whatever sort of job vacancy board where you will find job roles, you're probably going to see more and more AI engineers there. I think when ChatGPT was released, we had a meme going around on Twitter where people said, in a few years, we will all be prompt engineers. I think we're well beyond that point. Prompt engineering is important when you work with AI, but building applications, implementations around AI is getting more important than just doing some prompting. And for this, we make use of all these foundation models, which we like to call LLMs. So there is a ton of different models available. You have the GPT models from OpenAI, you have the Lambda models from Google, which are now actually rebranded to Gemini. Then there are the Llama models from Meta, and these are actually one of my favorite ones. They're open source, so in theory, you could run this model on your own machine. I have a video of this on YouTube on how you can run your own model directly on your machine. It takes a couple of gigabytes, so it likes to get slow, and if your computer doesn't have the best GPU, then it will actually be slow. So I work at IBM. We have our own models, which we call the Granite series of models. And then you have Claude from Anthropic, which is also a really good model. And then Amazon has their own models as well. So basically, a lot of companies are releasing models, so you don't have to stick to one model. You can use all of these different models side by side as well. So it's really good to know that you don't have to be a client or a customer of a specific company. You can run your own models. You can use open source models that are running on tools like Hugging Face, which is some sort of a model provider. And then there's all these models you can directly get at its origin. And the way we access these models is through APIs and SDK. So APIs are a really easy way to work with models because everyone knows, at least most developers know, how to make a call to an HTTPS endpoint using curl or using fetch or using whatever sort of library in your programming language of choice. Most of these providers also have SDKs, which are in Java or JavaScript or Python. So LangChain is a popular open source library, which is available in JavaScript and Python. And using this library, you can actually wrap all sorts of LLMs from different providers and get some sort of abstractions on top of it. Then OpenAI has its own SDK, I believe, as well. But they also have API endpoints. So instead of using ChatGPT to get answers for your questions, you can also directly call their models using an API endpoint. And then at IBM, we have something called watsonx, which is also a platform to run models. So you can, for example, you can get the Llama models from Meta through watsonx if you would want to. And then on top of these APIs and SDKs, you can still build your own front-end, back-end, like integrations between systems, whatever you prefer. So in a bit, I'm going to have a small demo on how you can basically do the application part. And if you work on a front end, for example, I like to use LangChain because it's JavaScript, and most front ends today are JavaScript. As I said, they also have Python. So as originally, a lot of the work around LLMs was done by data scientists and data engineers. A lot of code to work with LLMs is in Python. But it's getting more and more adopted in different languages, such as JavaScript, but also in the Java and .NET world, you see a lot of new libraries popping up that help you to work with these different LLMs. So as said, you don't have to be a data engineer or data scientist. It's available in all sorts of programming languages. Meaning that every one of you that knows how to write code is able to build AI applications and work with models and build your own applications around it. For example, if you use JavaScript to build front ends, you only need to do 2 npm installs, which is LangChain. And then if you want to use models from OpenAI, which are generally speaking the cheapest and easiest models to get, you just need to install 2 libraries and you're able to run the system. And when you install LangChain, there's multiple things you can do. You can follow their getting started tutorials, you can browse the internet and figure out how to build something. But what are you actually going to build? Because doing an API call to an LLM is a simple thing. You put a question in your body of your HTTPS request, and then you will get an answer back. But this probably isn't the most sophisticated thing you can build, because doing this sort of straight call to the LLM just involves some prompt engineering. So I'm going to quickly show prompt engineering, just because we're here, and this talk is called Going Beyond. So we need to know, what are we going beyond of? So prompt engineering is basically engineering the prompt that you send to the LLM. So a prompt itself, it's something that's called a natural language task, describing the task that an LLM should perform. So your prompt, it contains your question to the LLM, but it also contains a set of instructions. And with prompt engineering, you're not only shaping your question in a way that it can be easier answered by the LLM, you're also structuring the instructions. And maybe you're also giving examples, or you're giving more context. Like maybe you have a bit of text that you want the LLM to base its answer off. These are all things you can do, and it's what we call prompt engineering. So it's not only asking a question, but it's also providing a bit of text around your question in order to get a better response. So it looks a bit like this. You ask your question is wrapped in a prompt. So if you use ChatGPT, the question that you type, before it reaches the LLM, it will be injected into a prompt. So even though as a developer or as a person using a chat assistant, you don't really know that they're taking your question and wrapping it in a prompt, which also includes instructions. So that's why, generally speaking, if you know how to work with APIs and you're using ChatGPT, I would actually recommend to go to the platform behind ChatGPT, which is the platform from OpenAI. And then you can actually structure your own prompts. So instead of asking your question in the code assistant or chat assistant, you can put it in a request to the API, and then you can also give instructions. So this is a really useful way to help the LLM give better replies to your answer. An example here would be, let's assume so I had to travel here to Coimbra. We got some help from the conference, of course, but suppose you're not getting help from a conference or from someone else to visit to a location. You can ask the LLM, like, take the role of a personal travel assistant. And by doing so, you're already giving instructions. And then you can say, answer the following question in detail. So you're asking for a detailed answer, also from the role of a personal travel assistant. And then your question is just a variable. You put it inside the prompt. So this is what we call zero-shot prompt. You don't give any examples, and you're going to assume the LLM is capable of giving you a good answer to this question. And this will work for general purpose things. Like if I would ask for recommendations for Coimbra, there's a fair chance that it knows about the university or the botanical gardens or maybe the river. If I ask a question about, I don't know, maybe famous citizens of Coimbra or laws in Coimbra, like can I build an additional story on my house? These are probably things that need additional information, so I would need to provide some examples so the LLM would be better in giving me an answer. If you want to build this, like very simple prompting in LangChain, if you were to write JavaScript code, and for Python it looks similar, you just need to import the libraries. You then connect to OpenAI, so you need to provide your API key there. Then you create your prompt template, where you basically put the instructions, and then the question becomes a variable. So if you are building a travel assistant application, for example, you define the prompt template somewhere in your backend, the person writes a question, and the question gets inserted inside this prompt. And then the only other thing you need to do is send this prompt to the LLM and collect the response. So it's only like, let's say, 8 lines of code in order to build your own connection to a model from OpenAI in this case, but LangChain works with models from all sorts of providers. And basically, this is all the code you need in order to build your very first AI application. So there isn't too much code involved, and I'd say most developers would be able to do this. If you're able to send questions, if you're able to send requests to APIs or send questions using SDKs, then it's just these 8 lines of code. If you want to build something more, a little bit more sophisticated, and this is still prompt engineering, I promise we'll go to more sophisticated examples later. Let's say you still have this personal travel agent application that you're building, and this time you don't want it to answer the question in its own creative way. You want to give a format for its reply. So what you could do is you can give it a set of examples, like input-output. So by phrasing my output like this, it's always going to return part of your question, and then it's going to give just a list of responses. So 1, 2, 3, these are my 3 highest rated restaurants. Or this is the best season to visit in summer. So I'm going to give it some instructions to give me answers in this specific format. And this is all still prompt engineering because I'm giving the LLM very specific instructions. And based on these instructions, the LLM will help me generate a question. So this is what we call few-shot prompting. You're giving a few examples, and based on these few examples, the LLM is going to give you the best possible result according to its own knowledge, of course, because right now the LLM is still trained on general purpose data. We didn't give it any specific context or specific information about the places I'm trying to visit. There is a couple of more examples of prompting you can do, and I'll talk about prompting as a talk on its own. So I'm not going to focusing too much time on this, but there's a QR code you can scan, and this will bring you to a online source which is called promptingguide.ai, and they have all sorts of examples for prompting. There's chain of thought, for example, where you sort of go inside a conversation with the LLM. You ask a question, you ask a follow-up question. You're going to give it examples like, in the case of A, please provide this. In the case of B, provide the other sort of follow-up questions. There's a tree of thoughts. There's self-consistency, where you hope to make the LLM self-consistent. And then there's something called react prompting, which I'm going to circle back to at the end of this talk. Because in react prompting, you're going to ask the LLM to react based on specific tasks you've described in your question, which is kind of interesting. So I'm going to give you a few more seconds to scan the QR code in case you want to know more about prompt engineering. So the thing I really wanted to talk about is not prompt engineering or how to interact with LLMs. It's also how to make LLMs aware of your own context. So in the very beginning, I showed you the machine learning model I built like 8 or 9 years ago, where I was training a machine learning model for a very specific task. I wanted it to distinguish between Chihuahua dogs and blueberry muffins. And today we have LLMs that are trained on general purpose data. So in order to make an LLM smarter on figuring out a specific task, we need to provide additional context. And one popular way to do this is called RAG. So this is retrieval augmented generation. So this is where you give the LLM context that it should use in order to answer your question. It's a bit more complicated than the previous, where we just send a request to the LLM wrapped in a prompt. So what we do this time, we're going to use a vector database. And has any one of you ever used semantic search? Like other than keyword search, just semantic search. Maybe if you build a search engine or you use things like Elasticsearch. These are all examples of vector databases. They vectorize your question, so they make vectors of it. And then based on these vectors, it's trying to find similar vectors in its database. So if you build a search engine and you ask about, you ask multiple words, or maybe you ask a specific question in Google, for example, they used to use vector databases before they were injecting AI in there. So what it does, it takes your question, it turns it into vectors, which is just representations of words or characters or tokens in numbers. And for this, it uses a embedding model. So if you build RAG, you always need an embedding model. And then it stores these vectors in a vector database. And as these vectors are available in your vector database, whenever you ask a question, it's able to look at your question, trying to find related vectors from the vector database, inject these back in your prompt together with a set of instructions before it goes to the LLM. So here there is actually multiple things happening. It goes to a vector database, it tries to find related context, and then it's going to put this related context in your prompt. So together with the question and set of instructions. And only then it's going to generate an answer for you. So there's an additional step here, which is the vector database. And the vector database is one of the most important things here because it helps you to find related context. So the way you, actually before doing RAG, you need to take an additional step. You need to upload data to your vector database. And this could be data, it could be all sorts of data. It could be hundreds of PDFs, it could be millions of PDFs. It could be data you pull from a database, store in a different format, and then inject into the vector database. If you are a bit more closer to the sort of the data world, you might have a data lake. that you put inside a vector database or that you know how to vectorize somehow. So what you would do here, you take your data set, you turn it into chunks. So chunks are smaller sets of data, so they are easier to upload in the vector database. And then they get stored in your vector database after you use the embedding model to create vectors. So the way to think about chunks is, chunks are basically a row in your database. So you turn your large set of data into maybe millions of rows of data, because you don't want to have too much data, otherwise it will take longer for the LLM to process. And then as soon as they're stored in the vector database, you can already retrieve them using vector search. So if you're looking for maybe tips about Coimbra in Portugal, if you use regular search, it's probably always going to look for Coimbra and Portugal in the same sentence. Whereas semantic search would be able to also look for Coimbra and Portugal separately. So that could be one easy way to think about semantic search. And LangChain can actually do all this for you. So I already showed how to use LangChain for some basic interaction with the LLM. LangChain is also able to vectorize your data, store it in a vector database, connect to the vector database to retrieve its data, and then again do the very simple prompting we saw before. And for this you only need a bit more of code. I'm going to show the code again later, but I'm just walking through it now. So what you need to do, you need to take your training data, and I'm going to have an example with just one small text document, but this could be millions of documents actually. But as you probably know, if you want to load millions of documents, you probably need to set up some ETL in order to do this efficiently. And I won't be able to do that for a small demo. And then I need to split the text into chunks. And chunk size is something that's quite important here. Because the larger the chunk, the more data will be in those chunks, the harder it will be for the LLM to get relevant chunks for all the questions you're asking. And then you need to store it in a vector database. And again, you're using the embedding model here. So the embedding model that you use to store your data should also be the same embedding model that you use to retrieve your data later on, because it's important to create the vectors. And then again, you can retrieve this building something that's called a chain or a flow. So a chain or a flow is basically the sort of overview I gave of RAG. Your flow is retrieved from the vector database, injected into the prompt, sent to the LLM, and then generate my question based on that. And in LangChain, these are called chains. In a lot of other libraries, they are called flows. So let me show you an example of this. For this, I go to VS Code first. So I have a small application running here, which I like to call my GPT. And tomorrow I'm doing a workshop in the morning. Maybe some of you have signed up for that one. In this workshop, we're going to build this application, and we're going to do more things, of course. But I'm also going to show you what it looks like. So I have one file, which I call langchain.ts. I'm importing some libraries from LangChain. So this is JavaScript, but you can also do it in Python. I'm connecting to OpenAI. I'm setting something called temperature. So temperature is a way to let the LLM know how creative it could be. So a temperature of 1 means it shouldn't be creative, it should stick to the facts. And then I'm defining which model I want to use. If you're looking to use this in a production environment, make sure to test different models, because different models can have different responses. They can also have different latency numbers. So the newer models, they could be quicker than the older ones. They're also more expensive than the older models. So it's always good to think about what sort of gives you the best results based on efficiency, but also based on price. So what I'm doing here, I'm storing some data in a vector database, and this is an in-memory vector database. If you only have a small set of documents, it might be worth it to load this directly, store it in a vector database, and use it in the LLM. So this is used a lot in something that's called chat with your documents. A lot of companies build these chat with a document implementation. So maybe you have a terms and condition document that's 10 pages long, and you want to know if there's something about a cancellation policy, or maybe about complaints, because you want to file a complaint because you're not happy with a specific service. What you would do, you would fetch that document, you would store it in memory in a vector database, but if you have large number of data sets, then you can also store it in an external vector database. You split it into chunks, and then you store it in the vector database. And whenever you generate your answer, you have your prompt. So in this case, I'm saying my prompt is take the role of personal travel assistant that answers question in a consistent way. And then you can give it some examples, like format it like this. And then you can do some more prompt engineering here. And in the end, you're chaining it all together with the context. So I want to answer the following question based only on the provided context, which is this context coming from the vector database, and then my specific question. So you're putting all these things together. You're putting together prompt engineering with data from a vector database. And then these are still like 100 lines of code, which is quite a lot. And I have it running somewhere. So let me first show you the data, so you know what the data looks like. So this is my data. It's a blog post about the top 20 things to do in Amsterdam. So I'm living in Amsterdam, and I can confirm these are pretty nice things to do there. There are also the more touristy things, but it's completely fine for this example. And somewhere in here I said, answer the following question based only on a provided context. So I have my application running in my browser right here. So this is a very simple app that I built, and it's just connecting to an LLM using LangChain. So I can ask it a question like, what are the best restaurants or museums, maybe museums, in Amsterdam? So what it will do now, it's a bit slower than you might want it to be, because it first fetches my data, it puts it in the vector database, the in-memory one, and then it uses my context. So based on the provided context, the best museums in Amsterdam include these ones. So if I would go back to my text, I can probably find all these different names. If I'm trying to do something else, like what are the best museums in Coimbra, it should actually fail because I'm asking it only to use the context and not the data that's been trained on. And then you can see the answer is like the provided context does not mention any museums in Coimbra or relate to Coimbra in any way. So this is a good way to make LLMs context aware, and also by doing some prompt engineering, have them focus only on the specific things you want them to focus on. And this will really help because at some point I was using my sleep tracker, which I thought was a good idea to get better sleep. In the end it wasn't, but that's fine. My sleep tracker had a function to analyze my sleep. So it could figure out based on sounds, like how well you slept. And then they had an AI feature that helped me analyze my sleep results. And it was able to analyze my sleep results, but I could also ask this AI feature, like, what are the best places to visit in Coimbra? And it will return the best places to visit in Coimbra, because the model it's using has been trained on general purpose data. So if you don't do prompt engineering when you make LLMs context aware or when you implement them in your products, it's going to spit out all sorts of things that are irrelevant to your specific use case. So prompt engineering is useful for that specific thing. So we saw the LangChain code. To build a RAG application in LangChain was like 100-something lines of code. And this was only the backend. So it's the calls to the vector database, connecting with the model, constructing the prompt template. You can also do this with less code. There's a lot of things happening in sort of this space. Myself, I'm also working on a new product, which we call Flows Engine. And this basically means that we are going to define all the steps of doing RAG, of doing QA, in just a simple flow. So you have step 1, 2, 3, or 4 or 5, no matter how many steps there are, all in a sort of abstract way instead of needing to write all this code. And it's a good thing because it's making it even easier for you to build AI applications, even when you don't want to build the entire backend yourself. So I can give you a quick demo of what this looks like. I probably have this here. So the only thing you need actually is this file, which contains flows. So if we look at RAG, for example, this could be an example of a RAG flow. You have your inputs, so this would be your prompt template, your question, maybe the temperature, things like that. You have your top-end docs, which is retrieving data from the vector database. If you retrieve data from a vector database, usually you don't retrieve one chunk. You maybe retrieve 2 or 3 or 4 or 5. And if you want to retrieve more or less chunks, it would also influence the quality of your response. And then it's going to put your context together with your inputs in a prompt. It sends it to the LLM, and then it's going to generate an answer for you. And the only thing you need to build this is basically this thing you have right here. You can also set it to upload your own data. So for example, I'm using a data set here that's very general purpose. It has information on music, it has information on wars, it has information on, I think, even presidents. So yeah, there's like 180 references to presidents. So this is a general purpose data set that could also be used to train a specific model. So in order to upload this, I need to run just a command that says collection deploy. So this will deploy my collection to the vector database. This can take some time depending on the size of your document. Like this is like 28,000 lines. But what it does, it computes embedding vectors to store in a vector database. It's going to put it in the vector database. And I can actually stop this command because it's going to take too long. And then the thing I need to do, I need to deploy my flows. So these would be my flows to retrieve data from the vector database. It deploys it to an endpoint. And then the endpoint, I'm able to use this endpoint in multiple ways. So I can use this endpoint using an SDK, much like here. So in 25 lines of code, I will be able to retrieve all the information. Or I can also, and I told you in the beginning, I'm going to show some GraphQL. I can also retrieve the information using GraphQL. So this is just a question based on my collection, which was the very long data set I showed. I have a question like, who are the interns in Grey's Anatomy season 9? So I'm going to assume there's some information about Grey's Anatomy in my, my data set. So if I search for it here, it's probably spelled differently. There's some information on Grey's Anatomy in my data set. And then I'll be able to ask questions like this. I can set parameters. And this time, I'll be able to create my own flows or chains using a line of abstractions. And then I'm able to ask questions using an API or SDKs. So this is a simple way to build your own RAG applications, because if we go back here, there's more things you can do than just build a simple RAG flow. There's also things called re-rankers. So sometimes you get information from the vector database, but you want to re-rank the results, because maybe you feel the results are ordered indirectly. And sometimes even you want to revalidate your context. So you might have results coming from your vector database, and instead of injecting them in your prompt already, you first want to verify them using another set of LLMs. So using a flow language like this, you would be able to do something like verify top and docs, like this. You would save it and then you redeploy it. And this is very useful if you don't want to major in building RAG flows, you don't want to major in building AI flows or chains, but you just want to use them for a specific purpose, like building your product or building your own code assistant, then this will help you to move faster. So this is a new product that we're building at IBM, also using some of the Watson-X models. There's a public preview, so if you would scan this QR code, you would be able to sign up, and then you get a message when we finish the product. But if you have any questions, then feel free to find me. So I showed two ways to build it. You can use tools like LangChain, which are open source, and you can connect them to most models. They do require a bit more code. And then there's new frameworks popping up, like this one, which would involve writing less code, and you can even deploy them to the cloud. And then a good thing to know is RAG is not the only way to make LLMs context aware. Because for RAG you need to build a flow, you can generate flows, or you can use things like LangChain. You can still do training or fine-tuning of your models. So let's assume you have a very specific purpose. You can take an LLM and you can actually fine-tune it by providing a large set of data that you want the LLM to specify on. So in the case of building a code assistant, you could take a general purpose LLM that's already trained at code, And you can feed it like your entire code base, and then have it fine-tuned based on your code base. So by doing so, the LLM will get smarter based on your code base. But this will take longer and is quite expensive. So unless you're like a company with 10,000s of people or making a lot of revenue from these specific LLMs, it doesn't make sense to do this. So you're more looking at RAG or maybe long context windows. Because long context windows is also interesting. You might have seen the announcement from Google that they were able to do like a 8 million or 8 billion parameter model. So this means that if you're thinking about long context windows, you won't need RAG because of inserting chunks from your vector database, which are the best fitting chunks based on your search term. It will actually insert all the data directly inside your prompt. And this is fine if you are Google and you have very fast computers, you have models running on your own GPUs, and you don't care about the cost. But if you're building like general applications using AI and you're not working for a company like Google, you can still use long context windows, but be aware it might be expensive or really slow. So that's why we have things like RAG set up. And then the final thing I wanted to present you is AI agents. So we mostly looked at prompt engineering and RAG, which are still sort of deterministic or rule-based. You need to build these flows. You need to build a RAG flow where you go to the vector database, inject it in your prompt, and you define all this yourself. So you have sort of control over the end result. Something that's popping up like for the past 6 months or so, and a lot of frameworks are implementing agents, but it isn't as sophisticated as building RAG. So with LangChain or with this flows engine, you will be able to build agents. But there's still a lot of things happening and still a lot of moving targets for this. But AI agents are, I'd say, more or less the future in building these AI applications. So if we go back to our question and our answer, there is something happening in between. I showed like deterministic ways that are happening in between. These are rule-based. But with agents, it's not so much rule-based. So I have a diagram here. I'm going to take some time to walk you through it. So you have your question. You ask it to your system, which isn't directly an LLM. It's a system built around an LLM. You ask your question like, what are a good one could be if you're building e-commerce. I've been doing a lot of e-commerce in my career, more than I wanted to, maybe. But let's say you want to retrieve today's orders and the tracking numbers of the packages that were shipped. If you do this and you work for the e-commerce company, you probably know you send a request first to one API and then to another API in order to retrieve first the orders and then for all the orders the tracking numbers. If you ask this to an AI application, the application would look at your question and it then needs to think or plan what it should do. Because it should do follow-up actions. It should find orders first and then maybe tracking numbers and then put them together in a coherent answer. So in order to do this, it will need a set of skills or tools. So as I said, AI agents is still like a new pattern. Some people like to call them skills, other people like to call them tools. So maybe you tried this in ChatGPT where you put a URL in there and then it's able to go to the URL and then retrieve data from the URL. But you still have control because you provide the URL. If you think about building agents, you would provide the LM application or the AI application with a set of skills. So these could be functions or API calls that it would be able to do itself. It could also be Python code or Java code or TypeScript code that it's able to execute because you provide the LM with a runtime. And based on your question, it's going to look at the set of skills it has, like going to your order management system or going to maybe DHL or UPS or whatever you're using for shipments, or executing a Python function that you provided a runtime for. And then it's going to act. And not only act, it's going to react. So it can act first, so it can retrieve orders from your order management system. And then depending on the results, it should maybe go to UPS for some orders, to DHL for other orders, and maybe for some orders it should go to a different system because it's shipped manually, or it's going to be delivered like by someone from your company. So it's not only acting by getting the information, it's also reacting. So based on the information the skills return, it's going to take separate actions. And within a chain, or sort of this flow, it could take different actions based on different responses from these skills. So it provides you with the answer, And then there's also an observability part, because it's going to look at your answer and it's going to figure out what it can do next time better. So these are agents. We sometimes also call them autonomous agents, because you provide the skills, but the LLM itself is going to determine which skills it uses and in what order. So in the near future, I think we'll be building these agents. And if we go one step back, personally, I think RAG will be one of those skills. So a skill of your agent could be go to my vector database and retrieve relevant context because someone uploaded a data set that will make sense for this. So maybe terms and conditions or invoices that you have for specific customers. So RAG will become a skill in the sort of world of autonomous agents. So the very short summary of this talk, I'd say, is building AI applications is just like building any application. There's code involved. There's some patterns, there's some concepts that might be new, but most of it is just API calls and SDKs. Something I like to say is LLMs are just an API call away. You don't need to run them on your own machine. They're everywhere. There's APIs, and a lot of different companies are providing access to LLMs using these APIs. So that was it. The QR code will bring you again to the new product we're building in case you're looking to find out more. Also find me on social media or find me here at the conference. So thank you. So we would have time for one question or maybe two, if you want to. Oh, we have one question in front.
You told you told about chunk size, and that was important.
Yes.
And you told also that a bigger chunk size leads to worse performance. Well, how do you fine-tune the chunk size?
Yes. So what you typically do is there are evaluation frameworks which you can run. There's a framework called Ragas, which is kind of popular. And basically what you do, you would take the same data set and you would chunk it in different ways. So first you chunk it maybe with a chunk size of 200 tokens. And then there's some overlap as well, because the chunks are having some overlap with the previous and the next chunk. So basically what you do is you use different chunk sizes and then you compare the results. So you send a similar set of questions to the LLM, but with different data sets with different chunk sizes, and then you can evaluate, like based on things like groundness or relevancy score.
But then you should expect something. You have an idea what the outcome should be, right?
Yeah, so what you typically do, you provide the question and the desired answer, and then the evaluation framework is going to find out which chunk size best fits your desired answer. But if you look at autonomous agents, you could actually say you have collections with different chunk sizes. It's the same data set, but different chunk sizes. And then the agent is going to determine if it's going to use the bigger or smaller chunk size based on its own history with this data set. Okay, thank you.
Okay. Hello, hello. 1 2 1 2. Hello. Can you hear me? Is it fine? Is it okay? Yes? Not yet? Sorry. Oh, okay. It's in the HDMI, yeah. Okay, let's use the adapter. Okay, it's better. Yeah, it's working. It's working. Sorry? Yes. Yes, yes. Okay. It's not really bright. I mean, no, it's okay. Yes. Okay. Okay, yeah. forgot to ask, but I have an introduction in the presentation. And do you know if it would be possible to turn the light on off at the beginning? Yeah, okay. Yeah. And the thing is, usually during the introduction, I'm not on the stage, but I don't know if I can go there because of the mic, you know? Yeah, thanks. Even there? Because there's the... Sure. It's just for the beginning. I need to go there after. Sorry? Yeah, yeah. This is what I asked. Yeah, yeah. Otherwise, you will have the. Mm. So you give the signal. You give the signal. How do I know when I?
You unlock this door with the key of imagination. Beyond it is another dimension. It is the middle ground between science and superstition, and it lies between the pit of man's fears and the summit of his knowledge. You're moving into a land of both shadow and substance, of things and ideas. You've just crossed over into the light zone.
You may not have realized it, but you just have left Jnation. It's going to be crucial to stay calm for what comes next, because you have been thrust into a new dimension known as the IT zone. So here you are in 50 after Unix, so in 2020 of our era, in a small country of Western Europe named France. You are now a project manager within its Ministry of Education. The French government has recently committed in modernizing its education system, and you have been tasked in leading this reform. Nevertheless, like any self-respecting organization, top-down is never far away. And you have been strongly encouraged to enlist the services of external consulting companies. Before you even have a chance to voice your concern, your manager explained to you that this directive comes from the big boss himself, slipping in the suggestion to add the McKinney consulting company in the bidding process along the way. So McKinney, you already heard about them, but you don't really know what they do. So you decide to go on their website, this one, the real one running in production. I'll translate that in English for you. Here. So for now, we don't see a lot about them. There is the Arc de Triomphe, which is a French sign that means that you're a winner, you know. But there is something really important there. You can see that McKinney is written with an S we don't pronounce in the IT zone, just because I don't want to be shot by them after the end of that talk. So the aim here is to know how they can actually help you in the reform of the education sector of the French government. By scrolling a bit, you have here their first value proposition. They state you had to be an accelerator of innovation in more than 200 areas of expertise, which means this is a quite big consulting company. But right in the middle, they state you have more than 5,000 technological profiles, which is a bit weird, right? Why are they just unfazing one of their areas of expertise? Does it mean this is more a tech consulting company than the other thing? But never mind. After that, they try to create some empathy with you by introducing you to some of their team members. But don't get them wrong, you're here on the home page. So they are not anybody. You have here the managing director of McKinney in France, one member of the global executive committee, and one leader of one business unit. And if you click on those people, they have a dedicated page. But unfortunately, it doesn't really mean a thing to you, right? Since it's not really helpful for your mission. Going back to the main page there, you have the first call to action that discover some other profile. So let's discover who are those people. And once again, they are not anybody. You have here directors and senior directors of McKinney, and each of them is leading business units, such as industrial strategies and operational transformation of industrial peers. I don't even know what it means, but sounds clever. There is the McKinney Cancer Center, so maybe they have hospital and medics. I did not expect that. And digital division, because who doesn't have a digital division today? But perhaps someone is dedicated for education. Doesn't sound well. Anyway, let's go back to the main page and discover what they're supposed to know, what you're supposed to do. After that, you have their publication. This is a good thing. This is a demonstration of the know-how. But unfortunately, you will see here nothing about education. Construction sector, health treatment. You have fusion nexus of carbon-free energy in Europe. So looks like they have physicists as well. Didn't expect that. But nothing related to education. And then you have one section taking the full page that invites you to work for them. And now you're really confused. Because you start wondering to who has been built that website for potential consumers like you, because here you're not even the profile for working for them, or for potential candidates. And it ends with the location of their office in Paris. So it's been a good 5 minutes on that website. You still don't know how they can actually help you, right? But when you led into that page, you remember that there were some menu on the really top of it. This is a great user experience, by the way, with a tab named Our Job. Let's discover what their job is. And it looks like their job is 3D rotating balls. So that will only emphasizes the feeling that they try to position themselves on the tech industry, despite the fact you don't really care about that. So you're really about to give up. When you see that little animation there on the arrow, it invites you to scroll a bit more. And what do you discover? They have a matrix organization with sectoral functional skin center. You don't really care about that, right? But if you dig a lot more, you will see that here there is a page dedicated to education with what they know about it, what they do with their clients, publications. And because they really like that formula, it ends with the people working on that business unit. With the top of consulting crop, you will only have here senior partners and partners. The poor little business analyst won't even get a mention there. So in the end, you learn more about McKinney organization and how they could, the org chart, than how they can actually help you. So you live then with a frustrating sense of being unfulfilled. And this feeling doesn't come from nowhere. This is a clear sign that you just encoded the IT zone. So the IT zone is a world where science and belief blend together. This is a realm governed by unseen forces that has a strong impact on how people will build systems. Because here, we might be tempted to point fingers out the UX designers of Makini for this poor user experience, but in fact, it exists a phenomenon beyond their control that partly drives them to design the website that way. To find this phenomenon, we need to go back to 1998. The New York Times published then a front-page story that altered the landscape of the IT zone by showcasing the remarkable achievement of the Dr. Jacob Nielsen. And despite what this picture might imply, he's not the one who invented the mouse, although he seems quite delighted to be holding one in his hand. Really weird photography, right? But the Dr. Jacob Nielsen at that time was considered as the guru of the web page usability. He's one of the pioneers of the user experience. And in the late 90s, he set out in a mission to make the web more usable. Because he noticed that at that time, companies creating their own website were trying to over-optimize one search engine indexing metric that you know as the... Sorry? I don't hear you. It's the SEO? CEO? SEO? You heard that, SEO? But in fact, something older than the SEO. This is the CEO. You never heard about that? That's the C-level ego optimization. But you're laughing, but it's a real thing. Actually, in an article he wrote in 1997, Top Tech Mistake for Web Management, top 3 mistake is letting the site structure mirror your org chart. He said that users should not have to care about how your company is organized, so they should not be able to deduce your organizational structure from the structure of your website. And a classic sign of a mismanaged website is when on the home page you have a button for each of the senior vice presidents in the company. Something you definitely didn't experience at all in 2024, right? So, he's backed up in his observation by another pioneer of the user experience, the Dr. Nigel Bevan. In an article of 1998, he wrote that organization often produce a website with a content and a structure which mirrors the internal concern of the organization rather than the needs of the user of the website. So that's why on the Makini website, they are pushing a lot about the fact that they're hiring and the fact that they are trying to position themselves on the tech industry, despite of the fact that you don't care about it at all. So since late 90s, we know this is a bad pattern. Why are we keeping doing such things in 2024? As you dig deeper for answer, you find yourself transported to a new area of the IT zone, and now you are in Redmond, near Seattle in the United States, in 38 after Unix, so in 2008. You are now the marketing directors working at Microsoft, and you are creating a strategy to boost the sales of the commercial hit of that time, that was, remember, the main product of Microsoft 2008? Windows Vista. No? Did some people cried about it? And suddenly, your boss burst into your office in a rage because one competitor just released that ad campaign.
Hello, I'm a Mac. And I'm a PC, here with good news for anyone who's ever been frustrated by Vista.
Oh, you're fixing the problem.
No, I'm making them easier to live with my new line of calming teas. There's Crashy Time Chamomile, just the thing to soothe the nerves after a Vista-related crash. Or if Vista's making your applications run slow, there's Pomegranate Patience. Now, mornings are raspberry restart time for
that's
me.
great, PC.
Also afternoons, but...
We should move on.
Yes, let's move on, Mac, to my line of Vista stress-relieving bath salts.
So it's a real ad they made. It's a complete disaster. Your competitor is openly mocking the flaws of your new flagship product. Because indeed, tired of the incompatibility problems and the frequent crashes, your customer are either choosing to going back to Windows XP, your previous operating system, or for the first time, they are going to the beaten Apple competitor. The pressure is so high that you have to let PC manufacturers to sell new machines under Windows XP instead of Vista. But in the midst of this unfortunate situation, two researchers from Microsoft and one from the University of Maryland began to wonder if they can turn this situation into an opportunity for a study. So they kicked out an analysis of the 50 million line of codes spread across the more than 3,000 binaries modules of Vista. And the aim of this study was to evaluate how well traditional quality indicators can predict software bugs in production. Because now they know which modules of Vista had production bugs. So they try to figure out if there is a correlation between the fact that maybe this module had a low code coverage and the fact that it had production bugs. So amongst those indicators, you had the code churn, which is the amount of code you have to change each time you want to add something. The code complexity, you may know that as well as the cyclomatic complexity. Dependencies in the coupling, code coverage, also know that as the test coverage. And pre-release bugs in the number of bugs detected before the release. But before doing that analysis, they added another indicator, which was the organizational structure, which is totally odd, right? Because this one is not technical at all. So to be a good predictor of software bugs in production, those indicators must have a precision and a recall as close as 100%. I won't explain the difference, but here are the results. And as you can see, the organizational structure had the best score. Surprising. So in this study of 2008, the researchers have demonstrated that in the case of Vista, the state of the organization was a better predictor of software bugs in production than the code coverage. So to paraphrase Peter Drucker, organization its code quality tools at breakfast. It's not sonar that will help you, that will be able to help you if you are performing some scale agile frameworks such as SAFe. Sorry for the people running SAFe, but in fact, they were trying to demonstrate one statement that was done several decades before, in 1975, by the Dr. Frederick Brooks. In the Mythical Man-Month book, he said that product quality is strongly affected by organization structure. By the way, this book is not for the faint-hearted believers in the Gantt chart cult, as it might give them a serious case of heartburn. So, do you sense that slight tingle at the back of your neck? This is because you have been taken another leap. Just to make sure you're still awake. This is the sound of the train pulling you to London in 46 after Unix, so 2016, and you make your way to the headquarters of the multinational online travel company you're working for as an architect. You have defined the architecture of the train ticket reservation system as follows. You found that it was the best solution to address the needs, the business needs of your company. Because your company is selling train tickets all over the world. But each country is handling the train differently. Since your company wants to offer a standardized and uniform user experience for your user, and don't want to do custom development for each of these countries, this architecture is broken down in 3 agnostic components regarding those countries. Here you have Rail Supply, which is an aggregator of carriers API, like Comboios in Portugal, I think, Renfe in Spain, or SNCF in France. Everything gathered in a single API. On top of it, you have Rail Shopping, which is dedicated for all the business logic, but agnostic from the countries. So you have here how to search for a train, how to select your seat, and so on, in a uniform form. And on top of it, you have the UI. So this architecture has been defined 3 years ago. It's now time for you to come down your ivory tower as an architect to see what the developers have done. Because you heard that even though those systems are quite new, they are already really hard to maintain in production. So you took a look at the code and, oh my God, what was delivered was exactly what we were trying to avoid. Each component can be divided by countries using if statements. And as a result, some features have been deprecated by country instead of being shared as planned. So what went wrong? Is it a matter of insufficient skills of the development team? After some investigation, you find that in fact, it came from one belief of the management, which is called the feature team. So the feature team is a concept which intends to boost the autonomy of a team by letting them to intervene in each layers of the information system to implement a feature. But usually that feature is an entire project, and once done, they will do something else. Who will maintain that? No one knows. And here the management had 3 teams that were each on different time zones, and they found that it would be easier to manage if they specialize them by country, right? Because, you know, the rollout planning production was to doing first an MVP for France, another one from the British market, and finally one from the German one. However, all of those teams are working on the same code base, but they have different managers, different time zones, different deadlines, different objectives. So they have little reason to communicate and collaborate, right? So this belief and the pressure to deliver led to teams protecting themselves for the others to secure the deadline using that if my case statement. And that's why we ended up in that situation. And the worst part of that story is that since the ownership of each component here is not clear at all, no one wants to bear with the cost of the technical debt. So it seems that the IT zone is trying to send you a message. It looks like that your user experience and your product design, the product and code quality, and your architecture are strongly impacted by your organization. So far, we have seen only symptoms. But what can be an explanation of all of those things? To find this explanation, we need to go further in history. In 1968, the Dr. Melvin Conway published then an article named How Do Committees Invent, where he explores how company or organization design systems. And now we'll do a little exercise that you will be able to reproduce on your own organization, but your management will get upset about it. So let's consider an e-commerce platform. It's made up of 4 subsystems. Here you have user management. Shopping is everything related to the product catalog and your cart, the payment and the billing system. A system can be whatever you want. It can be a web page, a software product, but it can be also your phone or even a car. Melvin Conway wonders if it exists a relationship between the structure of that system and the organization in charge of it. So he did a little exercise, and he figured out that whatever the context, you will be able to find for each of these subsystems a team in the organization in charge of it. Quite easy to do, right? But to make sure that the whole system works, some of these subsystems need to interface with each other. For example, here between user and shopping. In information technology, an interface can be data transfer through an API. What he points out at that time is that if you have 2 subsystems that need to interface with each other, then the related teams need to collaborate in order to negotiate a specification of this interface, a contract. And usually in large organizations, this cross-team communication is coordinated by a Scrum Master or Product Owner today. What we can notice as well is that when there is no link between subsystems, for example, shopping and billing, there is no requirement for the related teams to collaborate on anything. So Melvin Conway demonstrated then that there is a close relationship between the structure of the system and the structure of the organization in charge of it. It's not uncommon for a team to be in charge of several systems, right? In that case, the structure of the organization becomes a collapsed version of the structure of the system. Sometimes this is the opposite because you can have several teams on the same system. So what we can clearly see here is that there is a kind of similarity of the structure between the structure of the organization and the structure of the system. And this similarity is what we call an homomorphism. And maybe now you think that Melvin Conway didn't invent something groundbreaking, by saying that. But in fact, behind this homomorphism, there is some properties that can be really annoying when we build systems, and especially when we do software. To give you some example, let's say that we are really beginning of a project. We have the business need, the problem, but for now we didn't define the solution yet. However, the management has already defined this organization with these teams. As you know, the role of an organization is to find the best solution that meets the business needs by comparing all the possible solutions according to their advantages and disadvantages. So here, to simplify the problem, let's say we have only two options for the problems they need to solve. And let's assume that the second design is the best one here. But we are omniscient, right? For now, those teams didn't discover yet those solutions. If we compare the solution, what do we see? We see that in the second one, there is an interface between user and billing system that doesn't exist there. And there is a checkout subsystem here that has been spread across shopping and payment in the first version. So now, the million-dollar question is, will this predefined organization be able to discover and choose the second design, which is the best one? If you take a look at this organization, you see there is no formal communication between user and billing team, and there is no as well checkout team. So if you apply the homomorphism rule, they should rather choose the first option, which is not the best one. Why? Because user and billing team, they may not realize that by communicating with each other, by collaborating, they will be able to find a better design for the system by introducing here an interface between user and billing systems. But the worst part is about shopping and payment teams. How do you want them to envision the emergence of a checkout system that sits across their scopes when this is the management who has predefined their scopes? And that has a strong impact on the way they think about the problem, you know? And as you may know, usually in companies, the structure of the organization and communication is not really flexible. That's why this organization will be constrained in producing a system that looks like the organization. And the larger is the organization, the more pronounced this tendency becomes. That's why Melvin Conway says that the very act of choosing an organization means that you are making decisions regarding the design, explicitly or not. And the act of choosing an organization will narrow down the range of the possible solution by potentially excluding designs that could be better. To give you a concrete example of that, Melvin Conway talked about one organization in the 60s that were in charge of building a COBOL compiler and an ALGOL compiler. Because they had timing issues, they decided to split and assign 5 people on the COBOL compiler and 3 on the ALGOL one. As a result, the COBOL compiler ran in 5 phases, while the ALGOL one only in 3. Despite the fact this is quite the same software to build. But not everyone agreed with this observation. A new perspective came from Tom Cheetham in 1996 that said that if you were to task 5 people in building a COBOL compiler, that compiler will run in 4 phases instead of 5 because someone has to be the manager. But let's go back to, So this is just one effect about the organization regarding the structure of the system you build. But there is some other effect as well. So let's say, once again, we are really beginning of a project. Usually, we don't put a lot of people when we only have the problem to analyze to avoid overcrowding. So let's say we have 2 initial designers there. But a manager is never to find this matter, and a manager knows that they will be blamed if they miss the deadline without employing all the people they have at their disposal. And that will create some kind of pressure on the initial designers that would prefer tackling the complexity of the problem until they can reduce it in a way they can find a simple solution instead of having to fragment the knowledge by delegating to others. However, since the management deems it's too risky to proceed this way, they will have no choice but to delegate to reinforcement, themselves reinforce, to secure the deadline as much as possible. According to Conway, this is rooted inside the belief that work effort is something linear, meaning for some people, especially the Gantt chart people culture, the work of 2 people on 4 months is equivalent to the work of 4 people on 2 months. And to make fun of that, Frederick Brooks in his book said that the bearing of a child takes 9 months, no matter how many women are assigned to the task. But let's go back to our organization that has grown a lot. As you know, In companies, we have management guidelines, HR guidelines, such as 2 pizza teams, 1 manager per team, and these rules will shape the organization, establishing a hierarchy based on delegation. Because here, the initial designers, they have some knowledge already, right? So they will take the lead. So it means that we will have, the organization will take forms even before knowing what kind of solution we would like to build. And once the organization exists, it gets used. But now you have a lot of people, right? So you have to keep them busy. So what do? You take that problem and you arbitrarily split it and split it again to make sure that everyone has a small amount of it. It implies that some intersection of responsibility, like this zone in gray here, will go unnoticed. Because by delegating to subgroups, you have created scopes that will act as blinders for these groups. And this is basically what we call in management silos. So that's why there is no such thing as a design group which is both organized and unbiased. But Melvin Conway said something even worse about the homomorphism effect. He said that at the very moment we had delegation, we had a disintegration of the communication, which implied the disintegration of the quality of the system. Sounds complicated, but I will explain it in simpler words. So the initial designers there, they have to step back from the problem analysis to do some coordination, knowledge transfer. However, these step backs weaken their understanding of the problem. And now, if you take 2 people from hierarchically distant teams that need to agree about something like an interface, the decision-making process becomes even more complex. Because if they do disagree, what say management guidelines, what we should do? We go up the delegation chain, right? And we employ people that are further from the analysis of the problem. And if those people disagree, we go up again, involving people that are even more further from the problem, and most of the time they are not technical at all. And they have to take a decision in 1 hour regarding really complicated technical stuff. That's why in the end, the structure of the communication will tend to align with the hierarchical structure of the company. And by homomorphism, it will be reflected in the systems they build. According to Conway, this is why military people tend to create a system that looks like the org chart. If you take a look at a COBOL program, it's designed like a regiment in division and section. So that's why the structure of large systems tend to disintegrate during development, qualitative more so than with small systems because of that amount of people there. The disintegration of communication, Frederick Brooks illustrated it well in another way. He said that when we had 3 people in the team, we had only 3 channels of communication. But when we moved to 11 people, we didn't move to 11 channels of communication as well. We moved to 55 channels. So it means that the effort of communication is not linear at all. So it implies that the work effort cannot be neither. And we have seen also that a system built by 3 people won't look like a system built by 11 ones. And Melvin Conway adds that 3 well-picked people will create you a better system because all assumption of parallelism that might be true when you are peeling potatoes goes up in smoke when you are designing systems. And this tendency to add more and more people to secure the deadline will lead the organization toward its bureaucratic forms with overhead of communication and synchronization. That's why, in the end, it becomes necessary to restrict communication in order that people can get some work done. This is counterintuitive, but this is true. Who here ever complained about having too many ceremonies or meetings? The others are Scrum Masters. I'm joking, but yeah, but it comes from there. Okay, so I didn't state it the law yet, But the Conway's law states that the organization which designs systems are constrained to produce design which are copies of the communication structure of this organization. So that's why on the McKinney website, the first thing you discovered was the org chart, starting from the top. And as you digged into the website, the further you were going down the layer of their org chart. The second thing you discovered was their matrix organization, even before knowing how they can actually help you. So this is a good example, even today, where you have an organization that has its communication structure that perfectly aligned with their organizational structure and ended up in the systems they built, their website. In the case of the online travel company, despite the fact that the system was thought to be agnostic from the countries, the teams ended up by creating a country-divided systems because they were themselves organized by country. And you have seen also that in the case of Windows Vista, the quality of the organization has a strong impact on the quality of the software. So that's an homomorphism effect because one property on the organization has a strong impact on the same property on the product, the system. I didn't told you what they put inside organizational structure. They were checking 8 statements. I only listed 3 of them, and I will have time to read one of them only. The closer the person with decision-making power over a component is to the engineer who built it, the better the quality. And as you can see, this is exactly at the opposite regarding the disintegration of communication that was saying Conway. And once again, it's not a coincidence. So maybe now you're wondering if we can avoid the Conway law. So in fact, you can't. It will apply whatever your context. However, you can learn how to better manage its effects. So Conway explains that the design effort must be organized according to the need of communication. What it means is that first your problem, you have to split it in smaller problems that will be easier to solve. With that, you will find your subsystems. Then the subsystems, you need to define the ways they need to integrate to each other to make sure that the whole system will work. And once you have that, you can define an organization in a way that its structure of communication will be restricted to what is strictly necessary, according to the interfaces here. However, the first design is never the best one, and we know that businesses will evolve with time. So it means that this organization may be flexible enough in its structure to be able to continue designing or building software effectively. So here, without explaining how to proceed for each of these steps, Melvin Conway just created a new kind of organization and system design that will be called later as the inverse Conway maneuver. So this term was coined by Jolly Leroy and Matt Simmons in 2010, and the idea is to break down the silos between teams that limit their efficiency by reorganizing. However, it might not be realistic to do a reorganization in every case. And keep in mind that this is a structure of the communication that will be reflected in the system, not directly the hierarchical one. It will be easier to have an impact on the way people are communicating than addressing the sensitive topic of a reorganization. But in 2015, the IT zone sees the rise of the microservices. And James Lewis had this funny idea to say that a team should focus on a structure that corresponds to the systems they want to build, instead of asking existing teams to follow an architecture on paper. Otherwise, you will have the negative effect of the Conway law. So to see how to proceed an inverse Conway maneuver, I have to explain you one other model, which is the BAPO model, that will drive our way through the inverse Conway maneuver. So the BAPO model was coined by Jan Bosch, professor at the Chalmers University of Technology and former vice president of the Nokia Research Center. And the idea of that model is to say that you should always start by defining how you want to create values for your users and how you want to generate revenues. This is the B here, the starting point of that method, which stands for business. Once you have defined the business and how you will make money, then you can think about the architecture that will achieve that business and all the related technical choices. Once the architecture is defined, then you can think about all the processes required to build that architecture. And once the B, the A, and the P are defined, you can know now which kind of competencies are required to do all those things. So finally, you can think about the organization. But what Jan Bosch noticed is that usually the companies are not BAPO, they are OPAB instead, the opposite. They start with an existing organization, and they define processes out of sheer convenience from that. For example, you have Michael, since 10 years, he's a validator. You will end up with a validation process, even though you don't really know what's the value of that. It will create an accidental architecture driven by the past of the company instead of its future that will limit the ability of the company to do business and innovation. And he knows that, right? He was working at Nokia. Sorry for the troll, but anyway. And what is a bit remarkable there is that if we go back to Nigel Bevan, remember at the beginning of the talk, he gave us 5 steps to go over the problem we have seen on the McKinney website. And each of these steps maps perfectly with the BAPO model. But those steps are meant for a web page, so maybe you are wondering what we can do for a software product or information system. Fortunately, we have hidden gems in the IT zone that will help you to do so. The first thing we'll see to deal with the B and the A is a revolution that occurred in the IT zone in 2003 with the publication of that book, Domain-Driven Design from Eric Evans. So the philosophy of domain-driven design is to put in the heart of software development the business, and always starting with the analysis of the business before going to the implementation or defining the architecture. So domain-driven design separate 2 spaces, the problem space, which correspond to the business, and the solution space that correspond to the architecture. Because we all have this bias as engineer to be already constructing a solution in our mind before having been fully explained the problem. So the guy is just explaining what he needs, and you are just thinking about REST, about databases and so on, but you didn't really understand what he needs. So that's why we do that separation. And we should always start from the analysis of the problem. To do so, you don't really need some fancy organization. You just need to take the expert, the business expert, you put them in a room with cross-functional people, and you make them talk about the business. And the aim here is to map out all the business concepts, business characteristics, so we can understand what is the business need. And technically, you can do that through an event storming, which is a workshop invented by Alberto Brandolini. This is quite simple and really powerful. Just to explain you that really quickly, all the participants are listing domain events that they think they are really important in the problems they are trying to solve on sticky notes. And then we will organize them according to some timelines, as you can see here. That will map out the flow of business value creation, and basically it will also map out your feature. Once we have done that, we will list all the concepts that are inside those business events, domain events, and we will analyze their life cycle. We'll see that some of them will evolve together, created together, die together. Some of them will be transformed. For example, the cart, at a setup period of time, will become an order. That will mark out some spaces. And these spaces, in fact, are your subsystems. This is what we call in domain-driven design bounded context. And once you have defined those spaces, those subsystems, you can start to explore the solution space, meaning doing some architecture. But here, I will show you one way to do some architecture that will take into account the Conway's law. And we'll do that through what we call a context map. This is the only tool I know that will help you to detect if you will have some kind of a negative effect regarding the Conway law. So the first thing you have to do is to list all the subsystems, here, user, shopping, payment, billing, and so on, and then define the ways they need to integrate with each other, to interface with each other. So here we have the payment subsystem that integrates with the shopping one through an openness service. So openness service is the old name for API. You can consider this is exactly the same thing. I won't explain ACL, it's not really important for that talk. Once you have done that, then you have to define what is the power balance between the systems regarding the business. You can have several ones. I will only give the example of one here, which is mutually dependent. Mutually dependent means that if one of them fails, both will fail. For example, I'm adding something in my cart, but I cannot pay. This is a failure for the user, right? I cannot put something in my cart, but I can pay. This is a failure as well. This is the idea of mutually dependent regarding if they are successful from a business standpoint. And why are we doing that? Because after we will see how the related teams are working together to see if there is some kind of orthogonality between the power balance regarding the business of the systems and the way the teams are working together. So let's say that here the related teams are working according to a customer-supplier relationship. There are several ones, we will only see this one here. That means that the payment team here need to negotiate in order for its needs to be prioritized in the backlog of the shopping team. And the shopping team can say, nah, we'll do that later, because they have their own objectives. Is that a good idea when you know that if the payment fail, they will fail as well, shopping? Maybe they should enter another way to interact that is called the partnership, which means that they will have to create together their roadmaps, their backlogs, define how they will go in production and so on, to ensure they will be together successful. So this is basically a context map. I invite you to do some research about it. This is really interesting. I don't have time to explore every kind of relationship there is there. It was just to give you a sense of what is strategic domain-driven design that stands with the B and the A of the BAPO model. But that part won't give you much guidance on how to organize. It means that this is not domain-driven design. I will tell you if you need several teams on the same project, on the same system, sorry. And it won't talk about some supporting teams like the ops, the infrastructure. But fortunately for us, in 2019 is really team topologies. I don't know if some people heard about team topologies yet here. Okay, some of you. And team topologies, invented by Matthew Skelton and Manuel Pais, is a dynamic pattern of organization in the school of the inverse Conway maneuver that perfectly align with domain-driven design. It will help us to deal with the P process and the organization. So just to give you some insights, do you know how we build teams today, usually? We put more and more people until the team fits the complexity of the systems they are in charge of. So the more complex is the system, the more people you will have in the team. Team topology said we should do the opposite. We should rather limit the size of the software to the connective load of the team can handle. Otherwise, they will be drawn, right? So it means that the team should have enough bandwidth, mental bandwidth, to be able to design, create, operate, maintain a software. And it also means that you have a clear ownership between one software and one team with enough bandwidth to be able to be in charge of it. This is regarding some stuff regarding the process. I won't explain everything, but I talked about the dynamic pattern of organization. So I will explain you why this is dynamic regarding team topologies. To take some illustration there, so let's take again our e-commerce platform. In yellow here, you have the shopping and payment teams. Let's say that they discovered that there's too much heaviness around their interfaces with some duplicated work. What states team topologies is that they can enter a new way of interaction, which is called the collaboration, which means that they will work closely together for a certain period of time to find a solution to problems they are not used to, this one. But it also means that their cognitive load is really higher because they also have to deal with their day-to-day job regarding their own subjects, right? So that's why this period should be as small as possible, otherwise they will burn out. Let's imagine that they found this is the best solution, introducing here a checkout system. According to team topologies, here we need to figure out if it represents or not too many cognitive load for both shopping and payment teams. If so, we will pop out a new team checkout. But now we know how those systems need to interface with each other, like payment need to interface with checkout, checkout need to interface with shopping. So we can enter another way of interaction between those teams, which is called X as a service. It means that the shopping team needs to provide a service to the checkout team that can be a documented API in a way that they are enough autonomous in its integration regarding the checkout part. Because the aim here is always to restrict the communication to what is strictly necessary. So I won't explain everything about team topologies. You have 3 ways of interaction, 4 kinds of teams. If you want to learn more about it, you can go to teamtopologies.com. And as you can see here, according to their website, Docker is using that as an organizational pattern. So we have seen that with the inverse Conway maneuver, we'll be able to better manage the effect of the Conway's law using as a driver the bipolar model implemented by domain-driven design and team topologies. If you have any doubt, you have to know that Accelerate, which is a scientific study released in 2018 regarding excellence of software delivery, this study tends to support the efficiency of the inverse Conway maneuver. But before you leave, you have to understand that this is not a magic wand at all. Like Matthias Vera said in one article of 2022, changing the organization won't ensure you to have the desired architecture. Because if the system is rigid to the modification, changing the organization will have a limited impact. To say that in another way, changing the organization won't fix a bad design. So it means that you will have to invest in the sanitization of your system to make it more flexible, even before thinking about reorganizing. And once again, the Conway's law is a constraint that will apply on whatever you do, whatever you organized. And the inverse Conway maneuver, a tool at our disposal to deal with its effect, but which is not a silver bullet. Keep in mind that you should first try to address how people are communicating with each other. If it's not enough, you can go on the reorganization level, but most of the time it's not at your hand, right? You have to be a manager or director to do so. And if both are not sufficient, it means that you will have to do some trade-off regarding the architecture and therefore some trade-off regarding the business. So my name is Jnation. I'm a technical coach at Shodo, French consulting company. In my great kindness, I brought you back to Jnation, but beware of your belief and stay alert. Otherwise, you will find yourself forever stuck in the IT zone. Thank you very much. So if you have any question, you can see me after the talk. Thank you very much. Hello. Yes. Oh, it's really, it's really hard to say because it really depends on.
bigger venue. Ah, I'm mic'd up. Okay, I hear that coming through just fine. All right, I'm ready to put my presentation on the screen if we can arrange that. Okay, yeah, now I can move it over there. Need to- Yeah. A little difficult when it's behind me. No, then I can't see my speaker notes. Let me just. Ah, there we go. Didn't. So, ah, where is my cursor? Where is my cursor? There we go. Put that over there. Okay. And make that. Oops. No. Okay. Oh, that knocked it down from maximized again. All right, let's just get that back to full screen. Okay. Why is that not advancing? There we go. Hola, Coimbra. Eu sou Dave Aronson, o T-Rex de Codosaurus, e vou para cá para no meu pterodátilo de estimação para ensinar-vos, vos ensinar sobre algoritmos genéticos, mas vou fazê-lo em inglês. So, what are genetic algorithms in the first place? The category as a whole is an optimization meta-heuristic, meaning that each genetic algorithm is an optimization heuristic, which is fancy talk for the idea that the category as a whole is a category of shortcuts to find a good enough solution to some problem, usually something that would be computationally intractable by traditional means like brute force or precise calculation. Ideally, this will get us the best answer, but we'll usually have to settle for something just good enough due to constraints like time and money. There are lots of kinds of optimization heuristics, but genetic algorithms are unlike most of the others in that they are inspired by real-world biological evolution, mostly the principles of survival of the fittest, combination of old sets of genes, no, not like the ones I'm wearing, into a new set, and random mutation. The history goes back to about 1950, when Alan Turing, as in Turing machine, Turing completeness, Turing award, Turing test, and all kinds of other Turing stuff, proposed a learning machine in which he thought that the mechanism of learning would turn out to be somewhat similar to evolution. Nothing much ever really came of that. And it took a few decades before genetic algorithms as a whole got any serious traction. Then the first commercial product based on genetic algorithms, a mainframe toolkit for industrial processes, came out in the late 1980s from General Electric. In 1989, a more generalized toolkit running on PCs came out called Evolver. These days, MATLAB and other such tools usually have genetic algorithm facilities built in, and there are genetic algorithm libraries available for most major programming languages. In fact, someone just showed me one for Java over the lunch break. However, the actual uses of genetic algorithms still remains mostly rather obscure, not very publicly visible, and honestly, at least in my opinion, a little boring. They're used mostly for things like company internal scheduling and logistics, and of course still industrial processes and such applications. But once in a while, they do get used for something a little more interesting and more publicly visible. Most famously, in 2005, NASA, the United States National Aeronautics and Space Administration, used a genetic algorithm to design the antenna for its ST-5 series of satellites, which they then launched in 2006. No, that's not just a bent-up paperclip that got bent up by somebody fidgeting in a boring meeting. The NASA Jet Propulsion Laboratory website says, "Its unusual shape is expected because most human antenna designers would never think of such a design." And that's actually one of the great advantages of this approach. These algorithms are not so hampered by expectations of any similarity to past solutions, what an antenna should look like. They can come up with things that a human would never think of, but the numbers work out fine, so okay, they went with it. But today, we'll only be looking at much simpler problem domains, mainly for the purpose of making an understandable demo. So, how do genetic algorithms work? They consist of a series of 5 simple steps, plus an initial 6th one. First, we create a population of candidates, or in genetic algorithms terms, they're called chromosomes. But since every living being contains lots and lots of chromosomes in each of lots and lots of cells, I never liked that term. I think it just leads to confusion. So I just call them candidates. I've also heard them called individuals or solutions or phenotypes, if you want to use another actual genetic term. But most people don't know that word either, so I skipped that one too. The next step is to assess how fit each of these new candidates are, according to whatever criteria we want to apply. And we do this step mainly because it supplies the information needed for the next step, which is to ask, are we there yet? Or are we done doing the whole cycle, which I'll complete in a moment? This is usually based on the fitness. It could be based on some other criteria, and we'll discuss some of those later on. If we're not done, then we select some of the candidates to use in breeding the next population, and then, of course, we use the ones we just selected to actually breed the next set of candidates. Some of the previous population, especially the most fit, might be carried over into this new population, but usually not. And next is a very important but easily forgotten step, which is to mutate them, which gets you more diversity in the gene pool. And finally, we go back to step 2, assessing how fit each of these candidates are, now that we've created a new population and mutated them. You might want to take a picture of this slide and the next one, because between them, they're kind of the main takeaways about how genetic algorithms work at a very high level. I don't see anybody rushing to take out their phones. Don't worry, the last slide includes the URL for all the slides, so you don't really need to. Okay, I see one. I'll give you a moment. Okay. Now, this sequence of events could be represented at a very high level in code like this. Now, I know this conference tends to focus a lot on Java and JavaScript, hence the J in Jnation, but this is actually Ruby, which I chose because it reads very close to plain English. So even if you don't know Ruby, I'm pretty sure you'll understand at least the concept, if not, and probably rather, the actual code. Now let's take a closer look at what happens at each of these steps by walking through some examples. First, we create an initial population of candidates, but what is a candidate and how do we create one? These are different solutions to some problem, usually represented by different instances of the same data structure. And this could be any data structure we want, so long as we can evaluate how fit these solutions are for our purpose, combine two, or maybe more, old ones into a new one, and somehow mutate them. The simplest common type of candidate is a simple string of bits. And this will do fine for situations where your solution is a series of yes-no decisions. And that may sound simplistic, but there's actually a huge category of problems that boil down to this. You may have heard of knapsack problems. This is a subcategory of constrained resource allocation problems, if you want to get a little more formal. The canonical example is that you have a knapsack, or rucksack, or backpack, whatever you call it, and you have a bunch of items that you want to carry in it, but they won't all fit. Or maybe they total up to more weight than you can carry, or some other such constraint, or possibly combination of constraints. And you want to get the combination that will fit the constraints and has the maximum value. Now, this could be the literal cash value, or it could be something more metaphorical. In the usual illustration, you have a knapsack that you're taking on a camping trip. So, of course, you want to take those things that are going to contribute the most to your comfort or possibly even survival. For instance, common camping supplies would be much more valuable than, say, an accordion. To look at a more concrete example, let's suppose we know a farmer who has a smallish truck, and he needs to decide what to take to market every week. And on this farm, he has some cows, E-I-E-I-O. So among the things he can take to market are cows, milk, cheese, butter, ice cream, meat, and leather. My apologies to any vegetarians and vegans out there. For the sake of simplicity, we won't differentiate between price and profit or between meat and dairy cows. And even though it's rather unrealistic, we'll assume he always has some particular set amount of it on hand and can only take that amount. Now, his truck actually has room to take everything, but it can only handle 4,000 pounds, in other words, 2 tons. Don't get me started on our stupid American units. So that's going to be our constraint. His choices are as follows. You don't need to really pay much attention to anything but this total down here of 8,600 pounds, which would be a little over 4 tons, almost a little over 4.25. Now, we could brute force the entire solution space, going through all the combinations and seeing which of the ones that is light enough for the truck has the highest value. Or we could use another common heuristic specifically for knapsack problems of always taking the most valuable item that will still fit within our constraints. But let's see what happens if we use a genetic algorithm. First, we need a way to represent each truckload. And in code, that could look like this. You might think, well, that looks like we're just making a random number. Yes, we're making a random number with 7 bits. So we have a random 1 or 0 for each one of the possible items we could take. We could get as complex as we want in this function, like dictating a minimum or maximum number of different products, but I'm going to just keep it simple. To create an initial population, we could just create a bunch of these and stuff them into an array like so. And for those of you who actually do know Ruby, yes, this could be done in much more idiomatic Ruby. I'm just trying to keep it understandable for those who don't. So we create an initial population of 10 truckloads, which could wind up with something like this. Now, why 10? Because that's what fits on the screen at a decently readable size. If I were doing this for real with a more complex domain, I might use 100, 1,000, a million, whatever might be appropriate. But how do we get from those random numbers to these combinations? Behind the scenes, that translation might look like this. We have a list of items we can take, each represented as an instance of a class describing them with name, weight, and value attributes. In this example, it's an inner class, but it doesn't have to be. To check what's in our cargo manifest, we can just iterate over the items we could possibly take and see if the corresponding bit is on. But I'll just hand wave over those details to keep things simple. Anyway, now that we're done with the initialization step and we have our truckloads, we assess how fit each of these truckloads is. And we do this with what's called a fitness function. Surprise! Just how biological creatures might be a perfect fit for one particular ecological niche, but a horrible fit for another. A fitness function should reflect the fitness for whatever application we have at hand. In this instance, we know he's taking the stuff to market, so we want the just plain cash value. But any truckload that is too heavy for the truck is actually worthless, so that gets knocked down to 0. And in Ruby, that could look like this. We decode which items we want to take, sum up their weights, and again, writing the bit on function is left as an exercise to keep this code simple. And if those weights total more than the capacity of the truck, then that truckload is worthless, so we return 0. Otherwise, we use a similar technique to sum up their values. And again, we could get as complex as we want in this function, and NASA's antenna fitness function certainly must have been. But for instance, if the truck were even smaller so that the volume mattered more, we could take the volume of each item into account. We could even take into account the exact actual dimensions so that he wants to take perhaps a flagpole. The total volume and weight might be rather small, but its actual length might be too much to actually fit in the truck. Now, if we run this fitness function on our current population of truckloads and sort on the fitness descending just to make it easy to find the best one, we wind up with this. And you don't have to pay much attention to anything but the top one, the best truckload we have, is worth $20,000. So now that we've assessed how fit these truckloads are, we can ask, are we done yet? So what are our criteria for that? This function can be very simple, but it can take a lot of thinking to figure out exactly what it should do for best results. And you'll find that with some of the other functions as well. With a knapsack problem, a very good solution, and especially the very best solution, can be made absolutely worthless by adding just one more wafer-thin item and thereby exceeding the constraints. So what we're going to do is hold on to the best one we've seen and just try to outdo it. And we'll stop if we haven't seen anything better within 100 generations. Why 100? Pretty much random. It seems like enough for a good possibility for improvement. And since what we're doing is rather simple and the population is rather small, that's not going to take much time. In Ruby, that would look like this. When this code is initially parsed to define the function, we set the best combination as empty and the number of generations since we've seen it as 0, both as class variables. That's what the double @ signs mean. When the function is called, we increment the number of generations, look at the fitness of the current population, select the ones with a better fitness than our current benchmark. If there are any, there may well not be, we make the fittest one the new benchmark and reset our generation counter. Otherwise, we'll look at how many generations it's been since we saw the best one. If it's over 100, well, actually over or equal to, whatever, it's kind of hard to read there. Anyway, if it's reached the number of generations we want to let it go, then, well, that's our definition of done. So we return true, otherwise we return false. As usual, we could get as complicated as we want in this function. Not only looking at the maximum fitness, we could also check the average or the minimum, and we could look at completely unrelated stopping criteria, like some number of generations in total or some amount of time, whether wall clock time or CPU time, or even let the user click a stop button or any combination of those and others. Since we're not done in this particular case, the next step is to select some breeders to breed the next generation. The obvious way is to take the top 2, like so. We take the population, sort them, reverse them, so we have them in descending order, and just take the first 2. Out of our current population, that would get us these 2, our 20,001 and a fairly distant runner-up at 14,800. And there are a few other ways, actually many other ways, but a few other common ways to select the breeders. For instance, there's one called roulette wheel selection, in which they're chosen randomly, but each one has a chance to be chosen proportional to their fitness. So for instance, out of however many it totals up, this top one would have 20,000 chances to be selected, and that one would have 14,800 chances to be selected. You can think of it like being their number of tickets in a lottery. I think the roulette thing is a little misnamed. We could also take more than 2, whether to breed all pairs in that set, or maybe even to combine more than 2 at one time. And we can combine these strategies, like selecting 5 by roulette and then breeding all trios within that, or any other sort of complication we want to apply. Now that we've chosen the breeders, the next step is to actually use them to breed the next population. And the usual way to do that is called crossover. This consists of taking the data points, or in genetic algorithm terms, the genes, hence the name, from one parent up to some randomly chosen crossover point, and then take them from the other parent. And this can be extended in various ways, like with multiple crossover points going back and forth, but we're just going to use one, like so. We establish the crossover point for a particular candidate as a random number between 0 and however many items there are inclusive. Then we go through the list of items one by one, and if we've hit the crossover point yet, then we take the decision from the second parent, else we get it from the first parent. And this could yield results anywhere from 0 from the first parent and all from the second to the other way around. And as usual, we could get as complicated as we want here, like making some crossover points more likely than others and various other complications. If we do this once with a crossover point of 3, so that we get 3 values from the first and the rest from the other, that could get us a result like this. But this is just one of 10 results because we're making a whole new population. And the code to do that could be like this. You might notice that this is very similar to how we created the initial population. However, now, instead of each candidate being made from scratch, they're the result of breeding the 2 chosen breeders. And the whole list might look like this. One particular aspect of this really jumps out, and that's that there is quite a lot of family resemblance. None of these loads include a cow, or butter, or leather, and they all include cheese. And that's because both of our breeders were like that. If we were to just continue breeding the best of each generation, we wouldn't ever see any truckloads including a cow, butter, leather, or no cheese. But we fix that in the next step, which is to mutate them. And again, I'm going to keep it very simple and just give each gene a 1 in 4 chance of flipping. And in code, that might look like this. We iterate through the item numbers, and for each one, if a random number from 0 to 3 is a 0, gotta love those off by 1 errors. Yeah. Anyway, if a random number from 0 to 3 is a 0, we flip that bit. And again, we could get as complicated as we want in here, like having some genes more likely to mutate than others, or having a minimum or maximum number of mutations per candidate, or all kinds of other options. If we run this mutation function on our current population, we might wind up with something like this, where the green color means that that bit flipped. You can see that we now do have some loads that include a cow, butter, leather, or no cheese. Now we go back to step 2 and assess how fit this new population is now that we've mutated them so they're in their more or less final state. And that would get us this chart. Oh no! Our maximum fitness actually went down. You may recall our previous best one was 20,000. But don't worry, as you might remember from the "Are we done yet" function, we just hold on to the best one and try to outdo it, so we haven't lost it, no problem. However, this isn't really the best approach. Remember how I said that sometimes the fittest members of the previous population might be carried over to the new population? If I had done that, the maximum fitness would never go down, because we'd always have the one from the previous population. So the "Are we done" function could be much simpler and we'd be done sooner. But I didn't think of that until after I'd already done all the slides for this talk and I didn't want to change them. Also, I think this version is still worth exploring to show how the maximum fitness can go down and come back up later. So you're not necessarily stuck on a local maximum. Anyway, the next generation might look like this. And you might notice that now we're back up not only to, but over 20,000. So we have a slight improvement over our original best truckload. So we set that top one as our new benchmark, reset the generation counter, and keep going. And if we let this run to completion, no, I'm not going to bother with each and every generation, much to your relief, we might wind up with something like this. So we wind up with 26,000 with a truckload made of cheese, meat, and leather. So that's one complete run of a genetic algorithm. And if we wanted to be sure that this was the best that this algorithm could produce, we could just run it again. and again, however many times we want within reason. Because in the general case, it's so much faster than brute force, or in some equations, very precise calculation. Now, in this example, maybe writing all that code and running this multiple times might not be faster than brute force. But if we were dealing with more items for more truckloads per week, maybe per day, and more complex criteria, then yes, writing a genetic algorithm may well be worthwhile. Now suppose we want to evolve something completely different. Suppose we want to evolve a good set of statistics for a Dungeons and Dragons fighter character. So now our candidates are tuples, or if you prefer, tuples, of numbers rather than strings of bits. Dungeons and Dragons character statistics are strength, intelligence, dexterity, constitution, wisdom, and charisma, each one made up by rolling 3 six-sided dice, or 3d6, as we at least used to say back in the day when I played Dungeons and Dragons. And I will ignore how you could have extra strength sometimes. I'm just going to make that little simplification to the rules. Now, in Ruby, creating such a character might look like this. And again, defining the function, in this case roll, is left as an exercise just to keep this code simple. So if we create an initial population of 10 characters, that might look like this. Pretty fair to middling characters. Now that's the initialization step done with, so next we assess how fit each of these characters is. And we're trying to evolve a set of fighter stats. So these should be based mostly on the strength and constitution and a bit of dexterity. The intelligence and wisdom and charisma, not so much. But we don't want them too low because of occasional saving throws. I tried several different things, such as totaling up double the strength plus the constitution plus half the dexterity. But the other stats started to get too low, and even the dexterity was suffering. So then I tried prioritizing them linearly, adding up 6 times the strength, 5 times the constitution, and so on down to 1 times the charisma. But then the other stats started to get too high, and the characters were more generalized. So I finally settled on prioritizing them more exponentially, totaling up 32 times the strength, 16 times the constitution, and so on down to 1 times the charisma. So the upshot of that is that even though these functions can be very simple, it can be rather difficult to figure out exactly what they should really do for best results, whatever best results means for the situation at hand. And if we run this on our current population and sort them, we get this. So we have a range of 476 up to 760. Now that we have their fitness, we can ask, are we done yet? But again, what are our criteria? Let's say we're done if any candidate gets 90% of the way to the maximum score of our fitness function. I'll spare you most of the math, but the maximum is 1,134, so 90% would round to 1,021. And in code, checking that would look like this. Very simple. None of our current candidates score anywhere near 1,021, so of course we're not done. So now we select a couple of breeders to breed the next generation, and I'm going to stick with the technique of taking the top 2 most fit. Taking the top 2, we get these 2. And now the abstraction gets a little more obviously leaky because we're ignoring sexes. That's not even part of the data. We have no guarantee that these 2 characters will be a male and a female. So we had the same leak last time, but that was not so relevant. The truckloads weren't living beings, so I let it slide. Now that we're dealing with living, even if imaginary beings, whether they're humans or elves or whatever, it could become relevant. It could complicate our breeding function or our breeder selection function enormously, possibly even making it impossible to find a viable pair in such a small population. But fortunately, for the purposes of this demo, we can ignore that. So next we actually use these two breeders to breed the next population. And this time we'll use a slightly different strategy of essentially flipping a coin for each gene. Like so. We go through the stats one by one, and for each one we flip a coin, or as I said way back when, we roll a D2. And if that comes up a 1, we get the stat from the first parent, else we get it from the other parent. And that might get us a result like this. But again, this is just one of 10 results because we're making a whole new population, which might look something like this. And there are two things to notice here. First, the number of red and green, which I'm using to denote coming from the first or second parent, is not always the same, neither in a single candidate nor in the whole population. It's a series of random coin flips, so on average there will be 3 and 3, but just like with the truckloads, it could be anything from 6 from one and 0 from the other to the other way around. Second, we still have quite a lot of family resemblance. Even though now we have 2 possible values for each column, not just 1, there's only 2, which is still a lot of family resemblance. In genetic algorithms terms, what we have here is 2 alleles for that given gene. And we would have only 1 allele for a particular gene if it were the same for both parents. That would also mean half as many potential combinations. Assuming that both parents were different in each stat, we would have 64 possible values. If one of those stats were the same between them, we'd only have 32, and so on down to the base case of 1. Now, at a glance, these do look much more suitable to be fighters than our previous population, but we'll figure their actual fitness a little later. Just like before, if we continued just breeding the best of this population, we'd never see any change, let alone improvement. For instance, the wisdom would never be anything other than a 6 or an 11. But we fix that in the next step, which is to mutate them. And as usual, I'm going to keep it very simple and just give each stat an equal chance of either staying the same or going up a point or going down a point, though clamped within the valid range. So in code, that could look like this. So for each stat, we basically add a random number from 0 to 2 and subtract 1, which is essentially like adding -1 to 1. But then we clamp it within the valid range of 3 to 18. And as usual, we could get as complex as we want here, like giving it a higher chance of going up or coming down if it were already very low or very high to begin with, possibly even doing so by multiple points, or making some of these genes more likely to mutate than others. But as usual, I'm going to keep it simple. If we run this on our current population, we might wind up with this, where the green means it went up and red means it went down. Looks kind of like a Christmas tree up there. Now, looking at the values in each column, this highlighter isn't very bright, but you get the idea. Looking at the values in each column, you can see it's now much more diverse. So now we go back to step 2 and see how fit this new population is. And that would yield this result. Now we see that this new population is in fact much better suited to be fighters than the previous population. The old one ranged from 476 to 760, and now we're going from 635 up to 851. Significant improvement. But it's still nowhere near our stopping criterion of 1021. So fast forwarding through 6 more rounds, we finally get one suitable character with 18 strength and constitution, acceptable though subpar dexterity, that fitness function might still need a little bit of work, and surprisingly high intelligence. Now that's not a problem, but it is a bit of a waste. If we really wanted the characters more specialized, we could complicate the fitness function even more to do something like explicitly demand that all of the class's useful stats, in this case the strength, dexterity, and constitution, all be well above average, and forbid it to be well above average for the other stats, or at least apply some sort of moderating penalty. So now we've evolved a set of fighter stats. Let's suppose we don't need any more fighters in the party, but now we want a wizard. All we need to do is to tweak our fitness function just a little bit, like so. Now we prioritize intelligence, then wisdom and dexterity, and so on, down to strength, instead of almost the reverse. We could also make this take parameters and pass in a different ordering or something, but I'm just going to keep it hard-coded here for simplicity. Now, an initial population would look pretty much the same since we haven't changed how that's generated. So I'll spare you those steps, but after 11 generations, I got this with 3 characters, at least 90% fit to be wizards. They're mostly pretty good in the other stats, but not so much as to be obviously better suited for some other character class, except that top one looks kind of like a bard to me. Remember, though, that this is all very random. It may converge on a good solution more quickly or more slowly, and the fitness function may be good or maybe poor at getting just the right mix of alleles so that they come out just how you want. There are many other ways of using genetic algorithms. They can create images, even code. I started working on one to make music, but couldn't figure out a good fitness function, how to evaluate how good a melody is. Oh well. I'm also working on one to create a schedule for a conference, given what talks there are and what they're about and so forth. And May Besaron has a talk about using it to schedule college classes and things like that. So just think about it, and you might be able to come up with some problem you're facing that you might be able to use a genetic algorithm for. To recap what you've learned here today, genetic algorithms are optimization heuristics, which is fancy talk for shortcuts to finding good enough solutions. They're simpler than you probably thought, and they can use very simple functions, but it can be difficult to figure out exactly what those functions should do for best results, whatever that means. They're also applicable to a huge variety of problems, including ones so complex that they can think of solutions that we humans would never have thought of. Now, if you have any questions, I'll take almost 10 minutes worth now. And later, there's my contact information up there. As for the other URLs, that first one is for the slides in HTML and some additional code. And the other one, as you may have guessed, is for the slides as a PDF, complete with a script, which I've mostly stuck to. So, any questions? Yes?
Is there any other way that having crossover, like instead of choosing completely that gene from the parent, mixing genes, or is that just solved by the mutation step next?
I'm not quite sure what you're trying to ask.
Instead of taking either strength from one parent or the other, averaging it out, or some combination of the genes,
Oh,
or do we just use
yes.
the mutation to solve that?
Okay, the question is there some way other than taking the gene from one parent or the other, just literally
Mixing the genes.
right? as opposed to doing something like averaging the two. Yes, you could certainly use that option. I've not seen that very often, but it's been occasionally suggested. Just as a wild guess, I would think it would probably lead more quickly to regression to the mean, but if you do that before the step of then mutating them so that it could then go further away from mean, yeah, that might be perfectly viable. Okay, I see a hand for a question over there. Yeah, we have a mic runner.
So do I understand correctly that for this to make sense, there should be a big number of parameters, because I think rucksack can be solved in square, and testing 100 options will be less efficient than dynamic solution.
I'm sorry, I didn't quite understand that.
I mean,
I can take a stab at
make
what
it
I
more
think you might be
efficient.
asking. Does it matter whether if you have just like a few genes in
Yeah,
each
I mean,
chromosome,
this-
or is it better when there is just a whole bunch of them,
no,
a huge number?
The type of problems then itself, they should contain many parameters to make this more efficient than precise solution.
Yes, there are some problems it's just not worth doing this for. If it's sufficiently simple, yeah, it might be, in fact, easier to just code up a brute force thing rather than a genetic algorithm. Like if we only had 7 things we could take to market or whatever. But if we had like, a much more complicated number of choices there, or each one was described by a much larger number of parameters. Like if we had, instead of just 6 character stats, we had like 1,000 of them. Maybe we're doing that huge number of dimensions for I forget what they call it, but for a large language model. Then yes, that would be much better of a candidate for a genetic algorithm. Basically, the worse it would be to brute force or do precise calculation in some physics things that require recursive refinement and so forth, then the better a candidate it is for shortcuts like a genetic algorithm. Does that answer what you're asking?
Yeah, thank you.
Okay, we have 1 minute left.
Yeah, he's very quick, so sorry. Regarding the
Five.
fitness,
Okay, never mind.
sorry. The fitness function definition, there are any golden rule or approach that we can follow to define it? Because the way I understood your explanation is just by trial and error that we try to understand which will be the perfect fitness formula to compute it, let's say.
I do not know of a good heuristic to find the perfect fitness function. I suppose perhaps one could apply a genetic algorithm to create the code to do that. It seems to me like it would be highly variable from domain to domain.
Thank you.
I'll try and research that, maybe for the next version of this talk. Okay, we have 4.5 minutes left.
Hi. What do you think the fitness function for the NASA and antenna would look like? Because since it's a physical thing, how would they evaluate its fitness? Do you think they could somehow simulate it?
Okay, I am not an antenna designer, So I don't know for sure, but I would assume, keeping in mind what happens then, that there are ways one can take an antenna design and figure out things like how much power it needs to generate a signal of a given strength at a given distance away, or some such things. Or I would guess there are probably other parameters like how precise the frequencies get. Maybe there's some noise it generates or whatever. And if anybody out there is an antenna designer, you can tell this guy the parameters of an antenna. And presumably NASA figured out how to evaluate those assorted parameters in some kind of code.
Okay, thank you.
I think that's all.
Okay, we have almost 3 minutes. Okay. Thank you. Okay.
Hello. Nice to meet you too.
Do you make your tasks from your screen just to see if everything's done?
No, I didn't.
No?
Yeah.
Do you like?
I mean, it's fine. Yeah, we can do that. Yeah,
Should I wait for your signal?
Hola, Jnation. Thank you for joining. It's a beautiful conference, beautiful weather. I'm originally Moroccan, moved to Stockholm 3 years back, and the heat started to get me, so I'm slowly becoming a Scandinavian. Sorry for that. I'm Mohammed Quickcontrol. I work for Spotify as a backend engineer. I'm a Java champion as of yesterday, so Thanks to all the Java champions that nominated me. Thank you. And I'm also a Google developer expert for Google Cloud. So for the next 15 minutes or so, we're going to talk about machine learning and the language that is not very known about doing machine learning stuff, which is Java. Language that I'm in love with for so long. I've been using it for at least the past 10 years in production. So I said, why not? Discovering what we can do with Java in the machine learning space. And before diving into the technical part, I mentioned it earlier, I moved to Sweden a couple of years back, like 3 years exactly. And then moving to a new country means a lot of things. Not necessarily good, not necessarily bad, but a mix of both things. One of the things that I had to do, and I imagine all immigrants has to go through, is learning the language, which enables you to learn the culture and get immersed into the culture. So you're an immigrant, you want to know what's happening around you, you want to have a conversation with the locals to at least be part of the society and the culture. Learning a language is not actually an easy task. So we've been looking at how people, or how to crack basically things as fast as we can. We as programmers love cracking things and doing things fast. Like all the best-selling books start with crack or learning fast or whatever. So looked for this book by Benny Lewis. And this book is basically telling his experience how he managed to learn relatively dozen of languages, approximately, and the technique that he used. So what he did basically is travel into the country that speaks the language he wants to learn, and then have with the little background that he has and the little words that he knows, just speak the language with the locals. No English whatsoever. And then what he does is basically start speaking the language, the locals will help him to correct the pattern, and then he will start building the patterns that enables him to build the knowledge. Now, to learn a language, there is two patterns. What Benny suggested is basically just immerse yourself with the culture, with the locals, with the people, and start speaking the language. What happens is you will fail a lot. I will miscommunicate much more, and then the locals will help you to correct the pattern. So basically, that's the learning by pattern. So you will correct, and they will correct what you say, and then you will learn that for the next round. And you will not learn the most grammatically correct language, but you will learn enough in order for you to have a meaningful conversation with the locals and the people that speak that language. The second one is what we all learn in school. It's very structured. You learn the grammar, you learn a little bit of the words, and then it helps you to build the syntax of the language and how the language is actually built. So we learn the subjects first, and then the verb, and blah, blah, blah. So we learn the syntax and the language and how its sentence is composed. So it's very ordered. And when it comes to programming, we are more into the second part. We, as programmers, are rule makers. So compared to the language, we learn the rules. So we, as programmers, our job is basically to dictate the rules to the machine in order to make it smart. So our job is basically writing the rules that we want. No matter how fancy your architecture is, no matter what pattern you use, microservices, container, whatever, you're basically writing rules to tell the machine to behave the way you want it to be, and making the machine actually smart to execute the task that you want. The picture in the example dictates a couple of things. Let's imagine that your product manager came in and says, hey, I want you to model a person that is walking. So you take that and you try to come up with a set of rules that enable you to model the real world scenario of a person that is walking. To do that, come up with a set of rules, come up with a unit of measure, and that unit of measure is actually speed. So we say if the person is less than 4 units of measure, you consider that person as walking. You ship it to production, it's working, it's fine. So that's your rule, basically. Then the product manager came in, because that's what product manager do. They ask for another feature, and that's to model a person that is running. So you use the same unit of measure, which is speed, and then you say that if the person is having less than 4 units of measures, it's walking. If it's more, then you consider the person of running. You deploy it to production, a lot of success. Product manager came in again, ask for another feature, modeling a person that is cycling. No matter. Like, it's not a big a deal. You use the same unit of measure, which is speed here, and then you add a new unit, which is 12. So if it's walking, otherwise it's running, otherwise it's cycling. So up until now, we'll be using the same unit of measure, which is speed. And then the product manager got really excited and asked you to model a person that is playing golf. Now, that is really challenging because the unit of measure that you have been using is actually not applicable when playing golf. There is no speed. The person is actually standing and just moving his shoulders. And that's when a lot of complaints starts, and then what we call the projects become a legacy because our set of rules got so stretched that we can't add anything to else. So basically to say that we programmers are rules writers. And the way we made the machine smart up until recently was basically to dictate the machines the rules and pass it the input and to try to match as best as we can the answer. And when the answer doesn't match, we basically tell that's a bug, and then we try to correct the rules that we introduce, which is our programs, and then to match as best as we can the answers. Machine learning is actually the opposite. Machine learning is actually the art or the discipline of feeding the machine with the answers and the data. We put it the input and the expected output, and we let it figure out the rules. So we are no longer part of the rules making process. We are more into collecting the data process and making the data meaningful for the machine to learn by itself. And that's basically what machine learning is. So machine learning is basically the science and everything that enable the machine to learn by itself in an autonomous way to make the rules in order to match as much as possible the expected answers that we want. And then the more the data is correct, predictable, the more data we have, the more precision we have, and the more the rules that the machine comes with are actually better. And when we talk about machine learning, there are a lot of words, especially in pop magazines. They mix and match a lot of terms. The artificial intelligence, machine learning, a lot of things, they seem to be the same thing, but they're slightly not the same. Artificial intelligence is actually everything that we are talking about. Is a discipline that started back in the 60s in order to make the machine smart. So basically, the idea is dump a lot of effort in order to make the machine behave the way we want them to behave and make them smart. So they achieved a lot of progress, especially in the fixed, well-known issues, like playing chess. Artificial intelligence excels in that, but the moment we put a fuzzy problem unknown, artificial intelligence as a discipline shows its limitation. And then machine learning as a subfield of artificial intelligence as a whole is started to be known in the 90s, and it is the most popular subfield of artificial intelligence. And it deals with large amount of data, and it deals with fuzzy problems, like classification of images, NLU, and all of that. And a subfield of machine learning is actually deep learning. So machine learning is basically feeding the machine with the data and the answers and let it figure out the rules. It's a discipline or kind of a similar thing as statistics. It's a subfield of statistics as well, mathematical statistics. However, it differs from mathematical statistics the same way that chemistry and medicine differs from each other. So machine learning deals with large amount of data, which traditional mathematical statistics doesn't deal with necessarily. So machine learning is a subfield of mathematical statistics that specialized in learning with large amount of data. And then comes deep learning. So with machine learning, we call it more. There's two types of machine learning algorithms. We call them shallow learning and deep learning. Shallow learning is one layer. So basically, you feed it with the data, it compute it, and then comes with the model that has one layer. Deep learning actually is having multiple layers. And the deep in deep learning is actually represents only the depth of your model and of your network. So that's why it needs a lot of resources, because we are, instead of doing
the computation in one layer, we are condensing and multiplying the number of layers. So the deep in deep learning is actually comes from the depth rather than in relation with neural, how the human body and the neurons work, or the human brains work. And then the last thing is generative AI that we're all speaking about recently. So generative AI is basically a subfield of machine learning, deep learning, and it deals with internet-wide data. It deals with a large amount of data, large amount of parameters, and it's so up until deep learning, our best job was basically we were telling the machine to predict the same data that it was trained to. So we're trying to predict the answer from the data that it was trained to. Generative AI and LLMs exceeds that by trying to come up with new things. So we have probably heard about hallucination problem in LLMs, and that's actually not a bug. That's actually a feature, because like LLMs are trained basically to come up with new things. So that's what generative AI is. Even in the name is generative AI. So they generate new things, and those things are not necessarily true, but that's how creativity works so far. So we're in the era of getting the machine creative, but we have to be really careful when we are dealing with those things. So hallucination, again, it's not a bug, but actually a feature. So we talk about that, and then what deep learning has achieved so far, a lot of things. Our machines and even phones now have a lot of machine learning features. So we can't kind of live with it. Every app in the world probably have a small machine learning algorithm or deep learning algorithm that is running on top of it. However, when I want to start, there's a lot of issues that stumbled upon. The first one is every tutorial, every book that was speaking about machine learning has to have at least one section about math, about statistics, linear algebra, vectors, gradient descent, and all of that. Now, I wasn't good in math in school, and I did enough to just pass and don't look back at it. So whenever I opened the book and found that, it's like, thank you very much, I'll pass. The second thing was Python. Now, Python is the dominant language when it comes to machine learning. Python is a great language, except when it comes to being environment friendly. But except that, it's a great language for data science and machine learning. However, I'm a Java developer. I would like to have an option. I would like to use Java when it comes to machine learning. And luckily, I wasn't the only one. A lot of people within the Java community started to the thought process around how we can make Java plays nicely with machine learning. And example here, Humphrey wrote a whole blog on how we can improve Java in order to make it a good citizen and plays nicely with machine learning and deep learning more precisely. And then you'll probably know that if you're a Java developer, Java is good for a lot of reasons. Scalability and performance, the WARA principle, integration, it's the dominant language in the enterprise world, and most importantly, the community support, or the community and support. This conference is a great show of how great the Java community is. And then the rest of this presentation is going to be basically, we're going to walk through 3 frameworks and 1 JSR. JSR 381, Visrec, and 3 other frameworks, Oracle Tribute from Oracle, the Deep Learning for Java from Eclipse, and then the last one is DGL from AWS. Starting with JSR 381. It's JSR, Java Specification Request, that is called for short Visrec. So it's a proposal to standardize the way we deal with machine learning, especially when it comes with visual recognition. And it standardizes the way we do it, making it less verbose, more Java-friendly, and it deals specifically with image processing and video processing. Things like image classification, object detection, and it also supports transfer learning and so on and so forth. I think better than having it a demo for it, right? So before that, how many of you watched the Silicon Valley series, TV show? Okay, couple of hands. Okay. So Silicon Valley was a few years back, 10, 7, 5 years. No, beyond that, 7. So Silicon Valley was like American TV show. It's when there was the Silicon Valley boom and startup boom and the internet boom. Basically, has this shows in ironic way how the Silicon Valley works and San Francisco startups, how they're pouring money in kind of dumb ideas. In one of the episodes, one guy started a very cool app called Hot Dog or Not. The excitement was big because like the promise was it's gonna detect. You point your camera to a plate, to a food, and it would tells you what the food is actually is. However, that's the case with every project, right? The expectation and specification is big, the delivery is not so much. So what he delivered is basically a app that basically, when you check a picture, it tells you if the app is a hot dog or not a hot dog. That's actually what the app does. And we will try to build the same thing with GSR 381 or Visric for short. But that's the video for the scene that was happening. So Visric, first thing, hello IntelliJ, hello? See that? Ryan, do you see that? I don't know what the problem with IntelliJ. It's like, it's becoming weirder and weirder. Okay. Okay. That's better. So you see how small and condensed it is compared to a Java program, right? It's like less than 10 lines of code to train your model, basically. So what we will do is have a list of test data or train data. So we have our data set. It's basically had a test and train folders. So I basically get them from, I forgot the name. I will mention it. Kaggle. So basically Kaggle have a lot of data sets, a competition, and one of them is hot dog or not hot dog. I have my training set, and it has a lot of ugly hot dogs pictures, and in the not hot dog, ugly pic. Oh, that's not so much ugly, but other things that are not hot dog, basically. So basically, we will train our model on those data sets in order to generate the image. So the model would be 3 things. So we will have our image. We'll do some modification for the image, basically. We will align them because like, the images are from different sizes, and we want the image to be standardized in order to have better results. So we will resize the images, all of them, to be exactly on the same size. And then we will split the images into multiple tiles. So the image 128 by 128, we will split it into multiple tiles, small tiles. And then our algorithm is called convolutional neural network. It's one of the algorithms for neural networks. So we will look for interesting parts for each tile. And that's what we call convolution. So we will split the image into tiles and then look for interesting parts. And then we will do some subsampling, which is we'll take those interesting parts and condense them into an array. And then we will repeat the same thing, take the generated array and then feed it to the next layer in our neural network and deep learning algorithm. Then we will repeat the same process for all the layers that we have, and then we will do subsampling, which is to match if it's actually working or not. So what we would have, since we are dealing with images, we have an image classifier that deals with images. In this case, Java, buffered images. So the input class is an image. We are specifying the width and the height of our images. We are specifying the labels in a JSON file. I like how they went for the convention over configuration. So we have, not this one, labels the text. Since we are having 2 labels that we want, it's either a hot dog or not hot dog. That's exactly what we want. That's what the app should do, and exactly what we do. And then we have the training file. And the training file is basically the index dot something. Yes, this one. So we took all the data set that we had, and then we labeled it. So that's basically the path of the image, and then the label that match this image. So we're telling our algorithm, this is the image, this is the data, and this is the answer part that we're feeding it. This is the image, and this is the label that matches it, basically. So the algorithm and the model will basically learn from it. And then we'll have our network architecture. A lot of, even in the Python world, a lot of frameworks and libraries actually define the neural network architecture in the program. With Visric, they went the other way and then defined it in a JSON file, which I find really cool. So we're basically doing the same thing that I said, like convolutional max pooling and then subsampling, or convolutional subsampling and then max pooling. So we are basically defining our input layer, defining our convolutional layer, which basically splitting the image into multiple tiles, looking for interesting part, converting it into a matrix, because that's math, and then condensing it, keeping only the interesting part, and then feeding it to another layer. Here, I have only one layer, which is cheating basically, because there is no deep learning with only one layer. But that's enough for training the machine, training the model on my machine, which is an M1 machine, 32 gigs, which is not bad. I was training it on a plane while coming here. And then fully connected, which is by condensing everything and checking if it's matched. And then we have the output layer, which is basically the last layer that we have. So in every deep learning model, we would have the input, the output, and then the fully connected. And that's pretty much it. We have the max error and then other configurations, which has the max error. If the error of the algorithm passes beyond that certain threshold, just stop. Don't continue training your model. Max epoch, how many times we want to do the learning rate, how the steps of the learning. And then when we finish, we want to export the model into hotdog.net, which is here. So I already trained it, already exported it, and that's pretty much it. So basically with this condensed code, 10 lines of code, and some configuration file, we're able to generate a very simple deep learning model. And then to use it, again in Java. You can imagine, this is a simple main class. You can imagine integrate with your favorite Java framework, Spring, Quarkus, you name it. And then what we do here is we import our model, which is a convolutional neural network. We are dealing with images, so it's an image classification model. And then we have our test data. So we have two things here. Hot dog. It's resources, Visric, something. Resources, Visric should be here. So we have a hot dog image, which is very ugly hot dog image, and then a pizza image, right? And then the intention here is pass this hot dog image or the other one, and then expect the model to distinguish if it's a hot dog or not. And then we get the results by running the model, running basically the inference. And then it's a simple model. We would basically assume if it's less than 50%, 0.5, we'll consider it not a hot dog. If it's more than 50% confidence score, then we'll consider it a hot dog. So running it here, it's switched to the hot dog image. If I run it, if IntelliJ is nice enough, I should get this. The image is probably a hot dog. Yes, that's what it says here. If I change it to the pizza one, it should say it's not a hot dog. So it's basic demo. It should work, but yeah, you got the idea. So that's basically Visric. They went the way of making things simpler, having a lot of configuration files for you to do things rather than having everything in one place, which make the code really readable, and then move everything that is configuration to specific files that you can define, which is really cool. Now move into another framework or another library, which is Eclipse Deep Learning 4D. They followed another pattern, and they were one of the first libraries that you can do deep learning and machine learning with. They're not so active recently for some unknown reason. I tried to ask, but got nothing. But the idea that they did is basically they defined the Java API. That's basically we use to build, train, and then run our model. So that's the API that we use, which is called Deep Learning 4D. And then they have another linear algebra library that they built, pure Java. It's called ND4D. That's the backbone of Deep Learning 4D. That's run the math that has all the functions, the methods, everything math specific that they use in order to make all the magic happens for Deep Learning 4D. And they benefit from a library called ByteDeco, which is a Java or a C++ library, and it does basically the switch between CPU and GPU. So with deep learning 4G, you can run your model or your training with CPU or with GPU, and they benefit from that from libND4G. And they have a data library, which is basically an ETL library. It has a lot of support for a lot of neural networks algorithm. A convolutional neural network, FNNs, RNNs, and all the major neural networks that we have or that we know of. And then the support exporting and importing from other frameworks like PyTorch and TensorFlow and Keras. Deep Learning 4G is very inspired from Keras. If you ever worked with Keras, you would find that the same thing applies for Deep Learning 4G. It's the same thinking, the same kind of APIs, the same way of dealing with things. ND4G, as I mentioned, is the backbone. It's a linear algebra mathematical library, so it enables them to do all the magic that they did. It has distributed training, and I think with combination with Spark, it goes even more nicer. Then it has multi-language support. Java and Scala, first-class citizen, they tried to do a Python API, but didn't work very well for them. And they have Model Zoo, and Model Zoo are basically a set of well-defined pre-trained models that you can use in order to, without doing the training, they are pre-trained for you. You can use them in your favorite or your production environment out of the box. Doing the same thing with deep learning 4G, look how longer the class actually became. Maybe zoom a little bit, remove this part. So deep learning 4G provides you with all the set of tools. Provides you with a toolbox, and they let you pick the one that you want. So it offers you all the tools that you would need, but then it comes with at the price of verbosity, and you would need to define everything on your own. Starting with defining your testing data set and training this data set. It offers you the possibility of switching and transforming your image. So the images we have is a couple of hundreds. That's not enough to train a well-defined model, right? Powerful model. So what they support is basically image transformation. So we can rotate the image, flip it, make it black and white, do a little transformation so we can have a bigger set of images for the model to train for more data. So they have that, and the one that they have is basically resizing the image. And then that's the definition of my neural network. And look how big it is. It's the same thing. They said I would rather have it in a configuration file rather than here. But yeah, that's what Deep Learning 4G did. And then it's almost the same thing, but with more machine learning stuff. So I find that with Deep Learning 4G, you need to know some of the things to get started rather than VisRec, which is like you can start without knowing all the things. For example, the activation, what does it mean? What algorithm should I use for activation for what use case? So those are the questions that you would need to ask, but they have a great documentation on the other hand, which is fair enough. So we define our neural network architecture with a set of options, and then we start defining our layer. It's exactly the same thing that I did earlier. So we start with a convolutional neural network, splitting the image into tiles, getting the interesting part, feeding it into the subsampling layer, which is trying to condense everything. And then here I have two layers. So I took the matrix that was generated from the first layer and pass it to the second layer, which is another convolutional neural network, which tries to look for the interesting part in each of the matrices and then have the subsampling. And in the dense layer, it's actually the max pooling and then the output layer, which is the end layer that basically generates the labels. And then that's pretty much it. So we defined our neural network, and then they have this thing called UI server. So it's basically a web image that you can embed on your application, and it sends data events to a web UI application that you can watch how your training is actually going. It's very useful, especially if you have a multi or distributed training. And then we're loading the data. That's everything that you can define. Notice that for VisRec, we didn't define anything. The library and the GSR took care of everything. So we're loading the data, setting up the model and some of the configuration, here as well for the web server UI. We're training the model, and then we are evaluating the model, which is basically have a training data, and then to see if the data is good enough or the model didn't do an overfitting or underfitting. So we're passing the test data to check how confidence our model is and how compared on how precise it is compared to the test that it did with our training data. And then we save it. It's exactly the same thing that we did. So that's a little bit more verbose, but it provides more tool set for you to work with and to do more fine-tuned building of your neural network model. Another thing that deep learning 4G supports, it's what we call transfer learning. Transfer learning is, the idea here is basically there are a lot of good models in the world, especially when you come, for example, in image classification. Imagine that you have an image classification as we have now. There are a lot of image classification models that are available in there. So you can use that, one of those models, and you can fine tune it in order to build your own model. And this technique is also supported with deep learning 4G. So the definition is exactly the same thing, but the number of layers is actually smaller. So we have only 2. So we are importing our neural network, which is a ResNet model. That is a very well-known image classification model. And then we are adding another layer, which is basically adds another testing, another training for the set that we want. And then everything else is exactly the same. So another feature that's supported in deep learning 4G, but not necessarily for GSR 381. Use cases for DGL, deep learning 4G, a lot of things. So it supports image recognition, that's what we show. It has also, you can use other use cases such as natural language processing, NLP, building chatbots, virtual assistants, and so on. You can build robotics and games with deep learning 4G if you want to. However, it has a steeper learning curve compared to other frameworks. And that's because they offer you all the tools and all the sets and the rich API that is a little bit more verbose. And that's because they have a lack of high-level abstraction. If you want to get started, it's going to be a little bit harder for you to do that easily. And then it's primarily focused on deep learning and neural networks. So if you just need some simple machine learning, such as regression and classification, deep learning 4G can be challenging. And as I mentioned that in the beginning, it has a slow release cycle, which is starting to get a little bit worrying. The third library, or the second library, is actually DGL from AWS. And DGL followed a completely different model. So instead of building their own engine, what they did is piggyback on the known engines that we have in the machine learning community, such as PyTorch, TensorFlow, and others. So they took those machines, put interfaces that basically forward to those machines and use their APIs, and provided a tiny Java API on top of those machines, on top of those frameworks and libraries. So it enabled us to be using the same things as everyone else in the community, or especially the machine learning community, and then use it with a Java API, with a Java flavor, which make it a lot more interesting. Yeah, so they benefit from the presence or the things that we do in the other Java or machine learning frameworks. They have another thing which I like very much, which is called DGL server. So imagine that you don't want to deal with machine learning at all. You just want to get an API from somewhere and then use it, right? I hope that I have Insomnia open. It's building. So DGL server is a very basic web server, web API, that's basically, host 880. That basically, forgot to download the model. It's basically, you can upload a model to it, and it provides 2 sets of APIs. The model API, which lists you which model you have, what specification of all the models that you can upload, and then it provides you with a prediction, which is based on, you can pick a model that you already uploaded, and you can do prediction based on those models. I have one that I didn't already load. Is it trace? Yeah. So here I just uploaded a model, which is trace ResNet, the one that I mentioned in Deep Learning 4G. I just downloaded it from the internet. It's basically PyTorch one, and then I will just upload it. It will take a couple of time, but it's available. So the model here is ready, as you can see. So I can basically use an API or a REST API to call it basically. So I will go to Insomnia and try to collections. No, that's work. That's so I have two, as I mentioned, two set of APIs. The first one, the models list all the APIs that I uploaded or the models that I uploaded into the DGL server. And here it says that I have trace ResNet 80 available and ready to use. And then here, I want to use the ResNet API or the ResNet model. So what I can do is basically try to go here, change the image, pick an image of something. Okay. And then sit. Interesting. Okay, what's the name? Trace ResNet 80. Okay. It should be here, trace ResNet 80. And then it will run the model and provide me with a list of image classification and the probability. So the probability of being a hamster is basically 85%. So in the real world, you won't probably need to build your own model. So you'll either use one that is available and tune it basically to serve your need, or using TransferLearn, or basically use one of those models. Because if you want to detect sensitive images or images that you don't want to use your user to upload to your platform, you can basically use one of those models that are already available, and basically use DGL server, and through a REST API, you can basically build anything using Java. But it supports everything using Java API. Another thing that I want to use, do you know Google Colabs? So Google Colabs or Jupyter Notebooks are a very known thing within the machine learning community. They used to be only Python, so in order to benefit from them, it's basically machines that some of Google, for example, offers, and Jupyter Notebooks and a lot of machine learning companies offer, free, that you can use with some constraints to offer you up to 2 GPUs and such. But they used to be very Python focused. But thanks to the GBank folks, we can now have an engine that supports Java. So that's basically the Visric example using Google Colab and Jupyter Notebooks in order to run it. So we can see that I'm using basically here GBank in order to import and install the Java engine. And then it will basically set for me a Java engine, which is based on Java 21. And then I will download my data set and then run my my training, which is really good if you want to do the training on a cloud environment. So that was DGL. Again, DGL has multi-framework support. For TensorFlow, PyTorch, MXNet, and all the known ones. It has a simplified deployment model, DGL server, really cool, really easy to use. And I forgot to mention that it's actually a Docker image that I was deploying. It's basically running in Docker, so it just Docker pull and Docker run, and it was really easy to do. It has an extensive model zoo. It's one of the best libraries when it comes to the model zoo compared to the others. Model zoo is basically a set of, as I mentioned, pre-trained models that you can use out of the box. It has automatic dependency management, basically because it supports multiple engines that are not necessarily Java. So it tries as best as it can to resolve that for you. However, that model compatibility is a problem because we are relying on other frameworks. They move faster than DGL, so there is a gap when they move. Like if a new version of PyTorch comes in that has a feature that was supported but you cannot use it until the DGL basically adds support to it. And it has limited deep learning framework support. I saw that in the community. It supports the well-known ones. You will find in GitHub a lot of people trying to add new things, but the committers in DGL wants to keep the focus on the well-known ones. The final one is Oracle Tribio. And Oracle Tribio followed a very interesting approach. So rather than focusing on deep learning models, they wanted to focus on machine learning specifically. And they wanted to focus on the enterprise world. So they offered a lot of solutions that help any enterprise company or enterprise environment to get onboarded into machine learning. So imagine you're an enterprise and you want to get onboarded in machine learning. So what you can do basically is Oracle Tribio. And what it does is you have a CSV or a text file. You have a database. You have a job, a pipeline that is running. So they have a lot of inputs that they can plug into your infrastructure, and they can transform the data for you and then shove it into their data source. So basically, they do the heavy lifting for you and then onboard it, map it to their internal representation of the data set, and then they do the heavy lifting and then train the model for you. Of course, you need to define your machine learning model and machine learning constraints, and then you will have to train your model basically and run it. It's all in Java, but it excels when it comes in enterprise environments and navigation to enterprise constraints. So as I mentioned, Oracle Tribio doesn't necessarily have a focus on deep learning models. It only focuses on machine learning models. For enterprise world, it does a lot of data pre-processing and feature engineering for you. It supports data pipeline. It's really scalable. Again, it comes with a lot of enterprise constraints in mind. So they try to make it a lot more easier for the enterprise world to get onboarded into the machine learning world, which is really cool. So what you can do with Oracle Tribio, anything that machine learning or classical machine learning excels at: classification, regression, anomaly detection, because they figured that not everyone needs a machine learning or deep learning algorithm or deep learning model. Not every problem in the world will be solved by deep learning. Machine learning excels at some point, excels in some scenarios, and they are a lot more cheaper compared to deep learning model because they have one layer, and that's for the enterprise world is saving costs, and most of the use cases doesn't need deep learning. However, as I mentioned, it's not focused on deep learning. If you need a deep learning library, Oracle Tribio will not be the one that you want to use. It has a less incentive model zoo compared to the others, but they are kind of building it. It has a smaller community, and that's because it's relatively new. It was released during 2020, so it's 4 years old compared to the others. But it's getting a lot of momentum. Keep an eye on it. So, when to use which? My favorite one is DGL, just because it supports deep learning and machine learning. The learning curve is smaller, and it supports PyTorch and what's the other one? TensorFlow. Those are the well-known ones, and everyone is using. So if you want to import and export to those frameworks, especially if you are dealing with machine learning engineers, it will be a lot easier. And it has an extensive model zoo. Deep Learning 4G, how to say it? If you have a lot of free time and you want to spend if you want to be an expert in machine learning, if you just want started and get done with it, then probably Deep Learning 4G will not be the one that you use. And then I mentioned that multiple times. The release cycle is really becoming really slow, so probably don't want to use that unless you know that it's going to be support for it. And then Oracle Tribio, if you're an enterprise world, if you're dealing with complex amount of data, if you just want to get your data and then shove it into an enterprise model and benefit from the machine learning, Oracle Tribio is really good when it comes to that. And that's just to say that machine learning is an engineering discipline. For multiple years, it's tried to say that it involves a lot of math. It's not really so. And then it involved multiple parts that Java was missing for most of it. But now we can use Java basically end-to-end from the training part up until measuring the performance of our machine learning model. Obrigado, and I'm ready to take all questions. Any questions so far? Going once? Going twice? Thank you very much.
C, A, C. C, A, C, S.
Will these lights be on during the talk? Because my slides are like full white background and it's going to wash out a bit. Let me know if you think it is being washed out. Okay. Okay, cool. Yeah. It was okay? Okay. Cool. Look alive, people. I know it's end of the day, but anyway, how are you all doing? Having a good time? Enjoying the conference? Okay. You're lying. No. You sound too enthusiastic for the end of a day talk. Cool, cool. And thanks for coming. Thanks for coming to this talk among all the great ones. I'm going to talk about a passwordless future. How many of you are excited for a passwordless future? How many of you are excited to not use passwords anymore? Really? Okay. Cool. So I'm Deepu. I co-chair the JHipster project, Java champion, yada yada. Huge on open source, done a lot of open source work. Polyglot developer, mainly Java, Rust, Go, and TypeScript. Work as a developer advocate for Okta, working on security-related stuff, OAuth 2, all these kind of things. So that's about me. So first things first, right? Why do we even have to go passwordless? We have been using passwords for more than 1,000 years. It has been handy, as long as it worked, sharing Netflix passwords and stuff. That has been handy, right? So why do we have to move away from that, right? Because passwords are a huge problem. So Verizon publishes this report called Data Breach Investigation Report every year. And as per the 2023 report, 65% of all data breaches has something to do with credentials. So social engineering, phishing, credential sniffing, something to do with passwords. And the year before that, that was 70%. So that's a huge chunk of breaches that has something to do with credentials, or a major chunk that at least some of it could have been mitigated if we were not using passwords. I don't think it's a technology issue, it's a human problem. I don't think we are evolved as a species to use passwords properly, right? Because it expects us to remember things, not to share things, not to reuse things, and we have over a millennia has shown that we are not good at any of these. We are not reliable. We are always the weakest link, right? So trusting us humans with something like a password, which is knowledge-based, is not a good idea, right? And this issue, you might think that, it's not a huge issue. I use a password manager. What's the big deal, right? But how many of you know somebody outside of the tech sector who is security savvy, who is going and using password managers, who is making sure they're not reusing passwords and stuff like that? Most people don't, right? So this is a bigger issue for the common folks than the tech sector folks. So let's dissect this a bit. So there are a lot of issues with password, but the number one problem is that passwords are knowledge-based. It relies on something you know, which is problematic, right? Because it makes remembering passwords a hassle and also securing them a hassle. If you want a complex password, they're hard to remember. If you want simple, if you create simple passwords, then they're easier to guess. So there's always trade-offs. And there are just too many services these days to create and remember unique passwords, right? So, of course, as people in the tech industry, we use password managers, we know best practices, we kind of work around these issues. But again, people outside of the tech bubble, they don't have a lot of a lot of options. Nobody's going to use LastPass or Bitwarden outside of our bubble, right? They might use maybe the built-in password managers on Chrome or whatever browsers, but that's all. Even that, if they are prompted and if someone else sets them up or something like that. Some people, yes, of course, there are tech-savvy people who might be doing it, but not everyone. And the people who are not doing is a huge chunk compared to people who are, doing best practices. Also, social engineering. It's extremely easy to social engineer people. There have been big data breach incidents where the people involved were like 14, 15-year-olds who were social engineering people to get passwords and so. It's not that hard. There is a popular video on YouTube where this lady demonstrates social engineering a telecom company. They just play the sound of a baby crying and throw some emotional manipulative things at them, and they were ready to give up the password or reset the password. So it's not that hard. So again, social engineering works because passwords are knowledge-based. Another issue with passwords are they are phishable, right? Phishing is a huge issue, right? A lot of folks fall victim for phishing. We might escape, but a lot of people do. How many of you have gone to a phishing website and realized that something is wrong? How many of you have actually entered your credentials there? No shame in that, it can happen. Some of these phishing attacks are so cleverly orchestrated that it will be hard to guess that they were not the real page. You know, with websites where they replace the O with 0, for example, so even the domain looks the same. So there are very clever phishing attacks out there. Another issue with passwords being password is remote replay. So someone can access your account from another continent, and if you don't have some sort of alerts or second factor authentication setup, you wouldn't even know that someone accessed your account. How many of you know someone who got their, let's say, social media account hacked? Yeah, I know a bunch of people who got their Facebook accounts hacked because they entered their credentials into a phishing website and they didn't have any sort of 2FA, right? And most people outside of the tech, they wouldn't set up second factor authentication unless they are forced to. Nobody's going out of their way to do that. So most people in the world, they don't have 2FAs for most of their stuff. Maybe for their banks because they force them to, nothing else. Another issue with password is data breaches, right? So for a hacker, your website or your application is attractive only because you're storing sensitive information. And one of the sensitive information is passwords. Others like credit cards and these kind of medical info, these kind of things. But most websites storing passwords are a target because there is a huge market for stolen passwords on the internet. There are, you can buy a database of passwords and credentials on the internet. So there's a huge market for that. So it makes your application a target because we are storing passwords. So what if we can get rid of that and we don't have to store any passwords? So that makes our server less attractive, right, for these kind of breaches. Another issue is passwords are reusable and shareable. How many of you reuse passwords? Yeah, I do. I mean, there is only enough number of complex passwords one can remember. I mean, I think I can remember maybe like 3 complex passwords. More than that is like, I mean, I rely on my password manager, of course, but there are some instances where you have to, like, for example, some banks or the government agency who go out of their way to make it impossible to do like a copy paste or like, a password manager on their thing. So you would end up, they actually end up reducing the security because they do these kind of stupid things, right? Another issue with password is on the server side. For us folks who are building systems, right? Because passwords are so sensitive, we have to do extra work. We have to encrypt them. We have to do all this sorting, hashing, and all these things for passwords. We have to build second factor or multi-factor authentication flows to secure it further. We have to additionally secure our applications to make sure they are not breachable. We have to create recovery flows, reset flows, a lot of these things. Do you know a password reset costs around $70 to $100 for each reset, the overall cost. If you divide the effort that you spend implementing these things and the effort of people involved, maintenance effort and all these things. So overall, passwords really bad, right? Obvious solution for that would be to go passwordless, right? But we have been doing some sort of passwordless for quite some time, right? We have biometrics, which is kind of passwordless. Most of the times you do have an initial password to go in and then it is biometric, but still, right, to an extent. There are services that uses a magic link instead of password. They send you a link by email, you go there and you click to log in instead of that. Then some services send you one-time passwords over SMS or something. And then there are services that would send a push notification asking you to authenticate and stuff. But none of these help to reduce the problems that we have with passwords, because even these solutions are phishable. These solutions are remotely breachable. Even with these solutions, there can be social engineering and all these things. So it might have helped in some specific cases, but it didn't help overall. Right? So this is where passkeys come into the picture. So in my opinion, a passwordless future that we all really want and we all hope for is passkeys. So passkeys are nothing but a pair of mathematically linked keys, which is a pair of public keys. So they can be used for authentication. I'll go into details of that. So you probably encountered passkeys already. How many of you have set up a passkey? Cool. GitHub? LinkedIn. Cool. And how many of you got the prompt from GitHub to set up passkeys? Cool. So Okay, I thought the rollout was finished. Anyway, so more services, so GitHub, Google, LinkedIn, Facebook, a lot of services are already offering passkey support. So if you haven't done so, please go check it out. Set up passkeys, you'll thank me later. It's seamless, it's more secure, it's more convenient to use. So before we dive deep into passkeys and see what passkeys are, we need to understand some of the basic technologies that makes this possible. So I'm going to do like a crash course of the most important ones. Let's start with public key cryptography. So public key cryptography, they are nothing but a pair of mathematically linked keys which can prove that they are uniquely belonging to each other, right? So the private key, of course, is private. The owner of the key pair needs to keep that private key secure. The public key, of course, is public. You can put that in your social media profile or you can share them out, no problem, right? So public key cryptography can be used for two purposes. Number one, you probably all are familiar with encryption, right? So we use the same public key pair for encryption. If you have someone's public key, you can encrypt a piece of data using that, and you can send it over to the person holding the private key. And only that private key can decrypt the data. So that is how encryption works, right? Another use case is digital signatures. So if you have a key pair, you can use your private key to sign a particular set of data, and you can send it over to someone. And anyone having your public key can verify that this indeed came from you, because only that private key could have signed the data. This is how digital signatures work. This is how you are using PDF signatures and stuff. So a PDF signature is more trustworthy than your actual signature because it uses cryptography. It is impossible to fake that. Next piece of the puzzle is an authenticator. An authenticator is a hardware or software device which can create public key pairs and which can store them. How many of you used an authenticator? Cool. It's a very security-minded crowd here. Nice. So there are two types of authenticators. Right? So we have something called platform authenticators. These are authenticators which are built into a device. You cannot remove them from a device. So device in the sense a laptop or smartphone, whatever device, right? Which holds this piece of hardware, you cannot remove that. Examples, Touch ID, Face ID, your smartphones, Windows Hello, many more, right? So these are platform authenticators. Then we have roaming authenticators. These are removable devices that you attach to your PC or your smartphone via USB, Bluetooth, or NFC. So examples are YubiKey, Google Titan. Again, your smartphone can act as both platform authenticator and as a roaming authenticator. How many of you have a YubiKey? Okay. How many of you? How many of you have used a YubiKey? Like, cool. So I have this YubiKey with a fingerprint sensor. They have many models. They have a tiny one called Nano. They have ones without fingerprint sensors. So these are considered gold standard of security because of the way how they work. Right? So I'll get into a bit more details of that. But these are authenticators. They make passkeys possible. So another piece of the puzzle is called FIDO. So FIDO stands for Fast Identity Online. So it's a security standard from global alliance of security experts, industry leaders, and big companies. It's called FIDO Alliance. So they have this aim that they want to get rid of passwords and they want to make internet a safer place using cryptography. So that's their goal, and they come up with certain standards. And the standard that we are using for web authentication or passkeys is called FIDO2. So FIDO2, again, consists of two other standards. So it's made up of web authentication standard or web authn. How many of you are familiar with web authn? Web authentication? Okay, good. I have some explanations. Another standard which is part of FIDO2 is Client to Authenticator Protocol, or CTAP. So let's go and break them down. So web authentication is a W3C standard. So it provides a set of JavaScript APIs which you can use to communicate with authenticators, platform authenticators and roaming authenticators. That is what web authentication is. Just two main methods and some utilities. Underneath, web authentication uses a browser's credential management API, or in case of smartphone, the platform's credential management APIs. So it works with whichever platform they are using, and the platforms, they make sure all of them support web authentication. I think all major platforms today supports web authentication. So web authentication has three main components. So authenticator, we saw what an authenticator is. So an authenticator in the scheme of web authentication is responsible for storing private keys and some metadata. Then we have a relaying party. A relaying party is nothing but the server which requires authentication. So it can be your own server in case you're implementing your own solution, or an identity provider if you're using an OAuth 2 service like Auth0 or Okta or whatever. And the relaying party is responsible for storing public keys and any other metadata like usernames, credential IDs, and stuff like that. The third part of the architecture is the client. The client consists of your browser and the user. So the user is there just for providing consent, because passkeys flow always requires consent. We'll see that later. So the user is there for interaction. It is optional. In some cases, the user may not have to interact, but in most cases, the user have to provide consent. And your browser is responsible for sending data between an authenticator and the relaying party. So it just relays data back and forth between them. And the next one is client to authenticator protocol. So this is the protocol that we use to communicate with roaming authenticators, specifically roaming authenticators via USB, NFC, and Bluetooth. So the client platform, as in your browser, can already talk to the platform in case it wants to communicate with the platform authenticator. So let's say if you are on Chrome on Mac OS, right? So Chrome will talk to the credential management API of the browser, and the browser will talk to the Mac OS's platform authentication API to talk to the Touch ID TPM. But in case of roaming authenticators, we need a standard which is cross-platform and uniform everywhere. So we have CTAP2, and the browser will invoke CTAP2 via WebAuthn to talk to roaming authenticators. Can be USB, can be NFC, and sometimes Bluetooth. I'll come to that Bluetooth part later. So in short, with all this, passkeys are nothing but discoverable passwordless FIDO credentials. That's the technical name, but it's a mouthful, so nobody uses that. So passkeys kind of became the noun used for this. So let's dive a bit more. So there are two variants of passkeys. So we have synced passkeys. So synced passkeys have a better user experience, right? So in case of synced passkeys, the private key that your authenticator generates, right? So the key pair that your authenticator creates, the private key, it is stored on the authenticator, but also gets end-to-end encrypted and synced to the platform's cloud. For example, if you're on Apple Mac OS and you go and create a passkey, so the Apple Enclave, I believe it is called, the TPM that Apple uses, it creates a set of keys. It stores the private key locally, and Apple takes that private key, end-to-end encrypts it using your iCloud password, and then it syncs that to iCloud keychain. So all your private keys get synced to iCloud keychain. The same happens if you're using Google Chrome, for example. Google will do the same and syncs your private keys to Google Password Manager. Similarly, if you're using, let's say, Bitwarden or LastPass or any other password manager that supports passkeys, they can also do the same. They can also take your private keys, encrypt it, and store it in your whatever password manager vault that you have. So that is synced passkeys. And because of that, we have better usability because everything is seamless. You don't have to go register each device every time. You only need to enroll once in any device you want, and you will be able to use that private key in all the devices connected to that particular platform. For example, if you add, let's say, iPhone to your Apple ID, the private keys that you created in your macOS will automatically get synced to your iPhone. So the next time you go to the same website on your iPhone, you will have that private key there already. So you don't have to register again or anything. So that's the seamless syncing aspect. Another advantage of synced passkeys is that as an implementer on our side, like as application developers, right, we don't have to implement any recovery flow for synced passkeys. Recovery, all this aspect is taken care of by the platform. In case you lose your device where you created your passkey, right, your private key, that's not a problem because Apple Keychain already has that, right? So when you add a new device to the same ID, that gets synced to that new device. So you are not losing your private keys. That's the advantage. But the downside of sync passkeys is that theoretically it is slightly less secure because your private keys are being stored in a cloud. So theoretically can be breached, even though it is end-to-end encrypted with your credentials and everything, theoretically can be breached, so theoretically it is slightly less secure. The next type of passkey that we have is called hardware-bound or device-bound passkeys. So these are considered golden standard of security because the private key is stored only on that device. Nothing gets sent anywhere, nothing gets synced to the cloud or anything. This is mostly applicable for roaming authenticators because they have the capability to store keys and it will only store on that particular key. But also, for example, Windows Hello is also kind of device bound for now. I believe they're working on making it synced. But for now, there are devices which can be used as device-bound passkeys. The private key is stored locally, but that means we have the opposite of sync, right? It is not as convenient because, for example, if I'm using a YubiKey for device-bound passkeys, I have my private keys here, right? So that means I have to carry this around every time I need to log into the website. So if I lose this, it's gone. It's not synced anywhere. It's not backed up. It's gone. So which means each device I use needs to be enrolled, no recovery or backup, but it is the most secure option because in order to crack this, somebody has to physically get this device from you and a second factor. And these keys are always multi-factor. I'll come to that a bit more because especially for a passkey implementation, if you're using a roaming authenticator, you have to have the item, which is one factor, and you have to provide, let's say in this case, a thumbprint, and in some cases a PIN or whatever that supports, right? Same for platform authenticators. It is always two-factor. So it's always a trade-off between security and usability. There are use cases for both. Sync passkeys is meant for the masses because general public is not going to care about slightly more security. They are not going to bother to get like a YubiKey or something like that, right? So that's not going to happen. So sync passkeys is for the masses because most people will have an authenticator built into their device, like a Touch ID or Face ID or whatever. And device-bound passkeys are meant for technical folks. People in the IT industry, sysadmins, and people who are really security-minded, they can go for device-bound passkeys. So let's see how the flows work. So there are two flows when it comes to, is it a countdown or count up? Okay. So there are two flows when it comes to passkeys. We have a registration flow and we have a login flow. Let's see how the registration flow works. So for the registration flow, the user would go to the website, let's say a cool site, and click on the register button. So the website's client-side implementation will talk to the server, which is a relaying party, and ask for a challenge. The server will send like a random piece of data as a challenge, and in most practical cases, that's going to be like a byte 64 string, random string or something like that. So the client got the challenge, then the client triggers the web authentication API, the .create method of the web authentication API, and passes some metadata like username they want to use, the challenge, the domain of the website, and all these things are passed. So web authentication, when it is triggered, it looks for the authenticators in that system. So if it finds multiple authenticator, it will prompt you to select one. If not, it will go with whatever is default. And as soon as the user provides consent by like fingerprint or by entering a PIN or something like that, the authenticator will create a new public key pair. So this new public key pair, the private key is stored on the authenticator. So these are asymmetric private public key pairs, right? The public key is not stored on the device, only the private key is stored. And in case of the synced version, right? In case of synced passkeys, there is an additional step that your, let's say, Apple or Google or Bitwarden, it will take that key, encrypt it, and sync it to the cloud. So that is an additional step only for synced passkey. But for everything else, it just continues. So once the key pair is created, the authenticator also creates an object called attestation response. So this attestation response will include the public key of the pair, a unique credential ID for this, and some other metadata like the certificates used, what kind of authenticator was used, all these metadata. It will put all that in an attestation object and pass it back to your client-side implementation. So your client-side implementation will pass it back to your server, which is a relaying party. So the relaying party will validate this response to make sure it uses the same challenge that it issued. It has a valid SHA and all these things. It can verify that. And once verification is completed, the user is registered with the public key. Here, you don't have to do any additional security. Like you don't have to encrypt the public key. You don't have to make any additional security measures when saving this. This is public data, so you can just save it as it is. And the registration is complete, right? So now let's say I'm registered. I want to go and log in, right? So we go to the login flow. Looks extremely similar to the registration flow. The user begins login, goes to the website, clicks on the login button. The client-side implementation will talk to the server, ask for a challenge, gets a random challenge. It will now initiate the .get method of the web authentication API. Earlier it was create method. So there is just these two methods. It will pass the challenge to the method. Again, web authentication looks for authenticator. It finds an authenticator. The user provides consent. And as soon as consent is obtained, the authenticator looks for every key that is associated with this particular domain. Because when it created the keys, the keys are bound to the domain and the user. So now it looks for the keys that is available for this particular domain. The keys are surfaced, and the user can select. If they have multiple, they can select. If not, they will go with the default one. So once the key is selected, the authenticator. So this is an additional step in case of sync passkey and you're using a new device, because then the private key is synced from the cloud here. So it's an additional step for sync. So as soon as the user chooses passkey, the authenticator, again, this is all being done by the authenticator. For example, if you're using a YubiKey, it is done by that YubiKey, or the Apple's TPM chip, or your laptop's TPM, or your phone's TPM chip. So the authenticator signs the challenge that it obtained using the private key and creates an object called assertion object. Earlier it was attestation because you're registering, you're attesting. Now you're validating. So you're asserting, it creates an assertion object, it puts in the signed challenge, it adds some metadata and all those things and passes back to your client side. Your client side sends that back to your server. Now, the server already has the public key of that user, right? And now it got this object which has a signed challenge, and server already knows the challenge that it issued. So what it does is it compares these two with the public key and to make sure that they match. And if they match, that means whoever did the flow has the private key belonging to that public key. So it is same as digital signatures. So the user can be trusted because they possess the private key. So you are logged in. So this is how the entire flow works. And this has nothing to do with OAuth 2, OIDC or nothing. This is regardless of what kind of authentication flow you use, these steps are the same. So you can replace your password-based flow with this or your OAuth 2 based flow with this. Doesn't matter. It only replaces the password aspect of things. So that's both flows for passkeys. So now that we understood how passkeys work, right? Let's see how it solves the issues that we saw, because we are trying to move to passkeys because we have issues with passwords, right? I think hope you remember the issues that we had. So passwords are knowledge based, right? But passkeys are not knowledge based. They are discoverable credentials which you possess. So they are something you have instead of something you know, which is always much more secure, because something you know can be, someone can get hold of that and use it without your knowledge. But this, if someone gets hold of your key, you would know that. And it's also harder to do that. They are phishing resistant, because if you get a phishing website which looks very similar to your actual website, your authenticator will not surface any keys because the domain doesn't match, because the keys are tied to the domain. So phishing is not going to work. So phishing website will not do any. You cannot even force your way to enter anything here. You cannot, because you cannot get the private keys out of an authenticator unless the domain matches. And remote attack resistant, because you physically have to be present. Either you have to have the key, or you have to be at the device where you have the private keys. So remote attack is out of the question. They are breach resistant because we are not saving any sensitive information. We are only saving public keys, which is useless for someone hacking in. And by design, they are not reusable, because for every service you register, it is going to create a unique private public key pair. It's never going to reuse anything. And it is also not shareable with a star. Technically not shareable, but Apple somehow made it shareable. I think in Apple you can airdrop a passkey, which kind of beats the purpose, but yeah, shareable with a star, not shareable with a star. And the last piece is password management, right? So passkeys make that a little bit more simpler for us. So in case of sync passkeys, we don't need any recovery mechanism. Password reset is out of the question because you don't have to reset these things unless your company wants you to have this rotation thing, which is kind of pointless in case of passkeys. Other than that, you don't have to do any reset things because you're not going to forget these. If you forget the device or something, then you're screwed. So there's no forgetting and resetting aspect. And for sync passkeys, we don't need recovery flows because the platform like Apple or Google will provide that. But in case you're supporting device-bound passkeys, you would still need a recovery flow because device-bound passkeys don't sync the private keys. So you need some sort of recovery flow there. But still easier. We don't need encryptions and stuff for saving data. We don't need multi-factor authentication. So if you're using passkeys, you don't need multi-factor authentication. Because as I mentioned, passkeys are two-factor by default. So you're already giving one factor being you possessing the device and the second factor being a thumbprint or a pin or something. So there's already two factors. So you don't need multi-factor authentication technically. So if we start plotting this on a security versus usability scale, right? So passwords are of course the least secure, but it is very high on usability because it is convenient to use. Then we have a password plus some sort of conditional multi-factor authentication, which is slightly more secure, but slightly less convenient. Then we have password plus mandatory SMS or OTP-based two-factor authentication. Again, slightly more secure because it is mandatory 2FA, but less convenient because you have to go take another device and stuff like that. Then we have social login, OAuth to social login, which is much more secure because we are relying on the security of the OAuth 2 provider. Like if you're logging in with Google, we are relying on the security provided by Google or whatever service you're using. And the assumption is that their implementation is much more secure than ours assumptions. It is also much more usable because it is quite seamless. You just click on login with Google, and if probably you're already logged in with Google, so you just go into the website without much hassle. Then we have sync passkeys, which is much more secure than OAuth 2 social login, but also slightly more usable because it is also seamless. You don't have to go fetch another device or something. You have your authenticator in your device already. It's synced everywhere you log in and etc. Then we have a password plus a FIDO MFA. FIDO MFA is the same technology that is used for passkeys, which can also be used to implement multi-factor authentication. So if you're using password plus FIDO-based multi-factor authentication, it is considered as secure as sync passkeys, but less on the usability scale because again, you have to do two factors. And finally, we have device-bound passkeys, which are considered the golden standard for security because of how it works. But again, not that usable because you have to carry around these keys and stuff. I, for example, always forget to carry this sometimes, and suddenly if I want to log into a website where I use this, then I'm like, oh shit, I didn't bring that. So there is a usability issue there. I mean, not everything is honky-dory there. We have challenges, like with every standard. Web authentication being a W3C standard, you all know how W3 standards work, right? We are going to have inconsistencies in implementation between browsers. We are going to have some inconsistency between operating systems, for example. So not everybody is not going to play nice with everyone. So it's going to have that kind of discrepancies and stuff because we are relying on browsers and operating systems for this. Then there is a valid privacy concern of over-reliance on cloud providers. Like, do you want all your private keys also to be stored by Google? I mean, probably if you're already storing all your passwords with Google, then probably not a big deal. But if not, then there is a privacy concern there. You might have issues in enterprises where, let's say, if they are not allowing Google or iCloud or something like that, then you will have issues creating sync passkeys there. Of course, you can do device-bound passkeys in all these cases because it doesn't rely on any cloud or anything. And most probably for very secure-minded use cases or enterprises, that is what they would adopt, device-bound passkeys. But there are those concerns. And finally, for device-bound passkeys, we still need a recovery mechanism. We can get rid of that for sync passkeys, but in case you want to support device-bound passkeys, then we still need a recovery mechanism because there is no backup or anything. So let's see how passkeys work. I'm going to show you two examples. I normally live code this, but yeah, I don't think there is enough time to live code and show two demos. I'm just going to. Is it visible at the back? Okay, anyway, I don't think this matters much because I'm not going to live code. I forgot. I'm just going to start the server and show you how it works. Not this one. So I have a very simple Spring Boot application. Basically, you can create this application with these 4 or 5 steps. I just ran, start.spring.io to create a skeleton. I added a single controller for the slash endpoint, the root endpoint. Then I created an Auth0 account because I work for Auth0. I created an Auth0 OIDC application, and I updated the credentials to my application, and that's it. That's all the steps to create this application. You can look at the GitHub repository if you want, but that's all the steps there. So I'm going to start that. I can barely see my. Do you see my mouse pointer somewhere? It's so difficult to see from here. Okay, I found it. It's here. So I'm going to start this. So first I'm going to show how you can use your mobile phone as an authenticator. So one thing I missed to tell you was that in case you are on a system like me, I'm on Linux, and browsers don't support platform authenticators on Linux. Even though most computers have a TPM chip, Linux supports fingerprint sensors and stuff like that, but still Chrome or Firefox, they don't support the platform authenticators in Linux. So my only option is to either use a YubiKey with device-bound passkeys, or to use my phone as my authenticator, and in that case I can create sync passkeys, because I'll always use my phone to create the passkey. It is an additional step. I need to have my phone, but I can do sync passkeys that way. I'm going to show how that works. So it is called cross-device authentication, and this is where the Bluetooth comes into picture. So to ensure additional security, when you use your phone as the authenticator, the device, let's say in this case I'm using a laptop, right? So my laptop's Bluetooth must be on, and the phone's Bluetooth also must be on, and the laptop ensures that the phone's Bluetooth signal is visible, which means the phone is in a 100-meter vicinity. So it ensures something you have factor with that. So let's go to the website. Am I connected to the internet? Yes. Okay, yeah, just a bit slow. So I'm going to sign up with a new, I'm going to use, I don't have any email validation enabled, so it's fine. So I can create a passkey. Oh, I didn't sacrifice to the demo gods today. So, you know what? I'm not going to waste time on this. I'm going to show you the next one. I'm pretty sure I did something stupid there, as usual. I'm certain I did something stupid there. I'm going to use the other application. So the other application, I'll show what the other application is in a bit, but I'm just going to show you the demo first, because this doesn't matter. What matters is the demo. So I'm going to, yes. So the browser will give me options, right? So if you go with this option, it gives you a QR code where you can scan that with a mobile phone, and your mobile phone gets synced, and then you can create the passkey on your mobile phone. So, and in your mobile phone, you can use whatever, like your password manager or your Apple's ecosystem or Google, whatever. And if you have already logged in, for example, I'm on Chrome, right? And I have an Android phone, so Google already knows that. So it already shows my phone as linked there. So if I choose this and click continue, I'm going to get a pop-up on my, oops, too many things here. I'm going to try that again. I think I took too long. I hope I'm on the same network. Yes. Use my phone. Yes. Yeah, so I'm going to get a pop-up in my phone asking me to create, so it is trying to connect to the device because it is trying to find the Bluetooth signal, and for some weird reason it is taking quite long. I should have, devices couldn't connect. Yeah, I should have done a sacrifice to the demo gods. Okay, not my day, I guess. Come on. Come on, come on. Yeah, okay, it worked. Phew. So, and I have already set my phone to use, let's say, I have a Samsung phone, so I use Samsung's, the on-device key, like password manager, so I'm using that. So I created a passkey, it asks for my fingerprint, done, and so they communicated and the passkey is now created. So now the passkey is saved in my Google account. So I can go in any device and where I have my Google account signed into Chrome or an Android phone, and I can use the same passkey. So this is how I would create sync passkeys if I'm on a platform where platform authenticator is not supported. So now I can sign in with the passkey, and it is going to, I'm not going to select this because it's an older one. I'm going to continue. And I get a prompt to select a passkey here, so I'm going to, yeah, it hasn't synced yet, so I'm going to try again. That's a small annoyance I'm having. I believe that's probably like a Samsung issue, I hope, because I didn't see that in another phones, because it takes 2 tries to get that last one synced, or a bit of time. It doesn't come automatically, and it still hasn't come. Let me see if the last one works. The one that I created previously probably won't. Oh, okay, it worked. Okay, so I just used a previous one I created. The one I just created with the test@test.com, it didn't. Oh no, I didn't use that, right? Oh, I used the Jhipster one. Oh, okay, that was the right one then. Yes, that was the right one, sir. Thank you. I was thinking of the one that I was using in the other demo. So let me continue where I left. Oh, yeah. So the first demo didn't work. I will look into. Probably I put in the wrong credentials or something somewhere. But anyway, so if you are building Java applications, and if you don't want to use an IDP like Auth0 or like Keycloak or something to take care of your passkeys and stuff, you can roll your own, like how you would roll your own password solution. So you have 2 options in Java. So there is a library called WebAuthn4j, which is 100% compliant with all the standards. It's Kotlin friendly. It is used by Keycloak. It has excellent Spring security support. So you can use this to implement passkeys in your application. Another option is Java WebAuthn Server from Ubico, which again, similar, but I consider WebAuthn4j to be a superior library because it is open source, it's better maintained, and has more options, or supports more formats than this one. But you can use either to implement passkeys in your application. So the application that I just demoed is something I built using Spring Boot and WebAuthn4j. Again, very simple application. I created a start.spring.io skeleton, added a controller, a Spring config, and I integrated WebAuthn4j and configured certain beans for that. So if you want to take a look, you can clone this repo, and you can look at the security config and the default controller there. It's only 2 files that matters, where the implementation is. It's quite simple to implement. It is as simple as how you would implement a password-based system with Spring security, right? It provides most of the things out of the box. You configure certain few beans, and voila. So you'll have passkey support. So this is that application. And if you want to use Spring security natively, passkey support is also coming to Spring security. So it is currently being worked on. Rob Winch is working on Spring security WebAuthn as a separate project, but it will become core Spring security, hopefully with 6.4 in November, hopefully. But yeah, it's in experimental state now. It provides a default registration and login page, so you don't have to implement that yourself. The WebAuthn example that I just showed, I had to implement the login page myself. It doesn't provide that out of the box. Whereas in the Spring security one, it will provide you login pages, registration pages and stuff. So you don't have to do much. You just need to enable passkey support in your Spring security config. That's it. So it's hopefully coming in November. that's kind of it. If you want to learn more, I suggest learnpasskeys.io is an excellent resource where you can see step by step what happens, what data is being created, what data is being sent to the backend, what you are getting from your authenticator. If you want to test out your authenticators and stuff, you can use that as well. It will show you, what data it gets out and all those things. So it's a nice way to visually learn how everything works if you're interested, and other resources for more web authent related stuff. And before I move on to questions, I work for Auth0, so if you want an identity provider, use them because they pay me. And yeah, we have some Spring Boot microservice workshops and stuff if you want to try them. It's self-paced and everything. Basically, we want you to try, sign up and try our platform. So that's about it. And I will take questions now. Thank you. No questions? Oh, great.
How do you think general users will start to adopt?
Yeah, I think right now we are being kind of like the beta testers as people in the tech world. I believe for adoption in the general public, it's going to take a few more years probably, and a lot more push. There is a lot more push from these bigger companies for passkeys, but still not at the level of general public yet. And I am seeing a lot more adoption in the tech world, because the first time I did this talk almost a year ago, I asked the question, how many of you use passkeys or know about passkeys? And like there were 1 or 2 hands. And yes, last week I asked the same at Spring.io with like I think 500 or 600 people, and like there were a lot of hands. And even today there were a lot of hands on passkeys users. So I think the adoption is increasing and the awareness is increasing. But the hope is that once the tech world adopts passkeys, there will be enough data to kind of see what issues we face, because there are issues, right? It's not everything is not smooth now. We have issues like, for example, if you have LastPass installed on your Chrome, it sometimes take over the flow from Chrome. If you want to use Chrome, then it is a bit annoying. So there are these kind of issues currently. So a lot more things needs to be ironed out. But again, we have to, be the path leaders using that and adopting that, and kind of, working out the kinks, and then I think general public will find it easier. And I believe general public will only adopt sync passkeys. Nobody's going to buy a YubiKey other than sysadmins and people who are forced by their company. Nobody else is going to buy a YubiKey. So it's going to be sync passkey. So there will be a lot more push for that. And device-bound passkeys, there are also some work going on in terms of figuring out if we can somehow have a recovery mechanism for that. But yeah, those are currently being worked on. So it will happen, but it's going to take some time. Yeah. Any other questions? Yes.
Yes, in the slide you've shown with the whole path, when you say the private key is associated with a specific yeah, this one. Yeah, when the over there. When
I think the previous one you're talking about, this one.
Yeah, it's pretty much
the registration. Yeah.
Yeah, when you say it's like that one is for cool site, does it fully rely on what to determine so that we avoid like one site requesting the authentication of another and stuff like that?
Yeah, so it relies on the domain.
Just fully on the domain and having HTTPS, I guess?
Sorry?
On the domain and having HTTPS?
Yeah, I mean, okay, that comes in later, but the first thing is I mean, your browser knows the domain, right? So even if you try to pass something else, it's not going to work. It is going to fail saying that the domains doesn't match. So you have to pass the same domain. So, and you cannot force that because browser will figure that out and stop you from continuing the flow. So yes, the keys are bound to your domain and also to the username that you choose, something like that. So that is how it avoids phishing, right? So the authenticator will only surface things that the browser tells which domain it is requesting. And you don't have a control over how web authentication API is talking to the browsers. That's not exposed to developers or the client-side JavaScript. Client-side JavaScript only gets 2 methods, get create, and some utility methods like seeing if there is an authenticator present and stuff like that. Nothing else is in the control of the JavaScript application. So the web authentication API, your credential management API, platforms, or they all work hand in hand to ensure that only valid keys for the domain that you are working on get sent. And in case you are working with iframes and stuff, there are certain options for that. But that's all. So you don't have any control to kind of spoof that or force that. But yeah, it is tied to that.
So I'm guessing like the whole passkey concept in general is fully for just working in a browser, not for supporting anything else? Or?
For now, it is on the browsers, but there is work being done so that you can use the same in Android and iOS, for example, because Android iOS already supports web authentication. That's how I'm getting that pop-up. I didn't install any additional application to use my mobile as an authenticator. I think the same for iOS as well. You don't have to install anything new to use that. The feature is part of the operating system. So it is already there. Yes, there is work being done to make it possible to use in native applications. But the primary focus for now is the web applications because that is the majority. So once that is figured out, native applications will come. But yeah, I think that is already there, worked on. Yes. Thank you. Anything else? I think 30 seconds, or I'll also be outside if you have. Want to chat further on this or something else. Thank you for coming.
So.
Are you sure?
Yep. Yeah. Because Okay. Okay, can we get started? Should I do something about the slides or? Sorry guys, that wasn't planned. I hope it didn't wake you up. It's the last session, so you're very courageous to be here. Thank you, and I'll try to speak slowly and try to do it like a story, so we get slided to the night easily. So today I'm gonna share with you a huge secret. Generative AI is coming. I know we are close to the house of God, and I know the secret will remain with us. We are not that many, and there are a couple of edges to what's happening. So I'll try to cover as many of them as possible. The thing is that they are changing very, very rapidly. So I'll try to do as much as possible today, because tomorrow it will be already history. I'm Olimpiu Pop. I'm working in the technology space for quite some time. In the last couple of years, I worked mostly on the research side, technology executive side. And most of the glitchy pictures up here are courtesy of my friend Steve Poole. He likes to kick my ass with jokes, and he did a lot of them. We prepared this presentation together. He's not here today, so I feel him closer, allowing him to make fun of me with these pictures. So on the right-hand side, he tried to see how I look after a career in IT. It's me at 20 years old, and pretty much that's it. And we have 4 big sides. We start with a big of history, moving towards a couple of examples of what happens in the AI space, how generative AI can change the things, and then we'll slide slowly towards how the landscape will change, how the things are going to be implemented, and to see how complex everything is and all the parts where we can have actors that are trying to step on our toes. Last but not least, we'll have to go to the cloud, because obviously everything is in the cloud. And let's get started. In the medieval times of the history of software, 2011, brother Mark Anderson, which is one of the biggest investors in the space, put a lot of money into a lot of the tools that we currently have in our pockets, had his first epiphany. And he said, software is eating the world. And pretty much I think we all agree with him. But the churn was quite slow. It started with Spotify that needed like 11 years to get to 100 million users. And then slowly it grew. Well, we have some of the big players that disappear now. They were X'd around it, so sorry for them. And then we got to the point where probably one of the biggest inventions of humanity, TikTok, needed exactly as much time as a woman needs to have a baby, 9 months. It reached 9 months to 100 million. Well, it's in China, so I don't think that's much, but yeah, let's give it credit for that to be here with the other ones. But last but not least, OpenAI needed 2 months. That's great, right? Or is it? And then, almost 1 year ago, 6th of June 2023, brother Mark Anderson had his second epiphany. And he said, AI will save the world. Well, even if we are close to the house of God, I have my doubts. Because if you look at what happens, currently, according to the Green Software Foundation, we as an industry use as much power and we put in the atmosphere as much carbon dioxide as planes, trains, automobiles, and everything else that means transportation. Well, that's not exactly something that I would like to say that we are saving the planet. But don't worry. We have Planet B. Planet B is around the corner, so when this one is dead, we just jump on a ship and we just fly out. And it's okay, don't worry. But if that's not enough, we are using the thing that we use a lot today. We use water. So probably until this slide, I used like a bucket of water for everything that I generated, because for each and every image generated and each call that we are going, we are using a bottle of water. Probably double this one. But don't worry, I told you. Planet B is around the corner, so we'll be there. But enough. Let's talk about the real great stuff that generative AI can do for us. And this guy, I learned about him how to traverse graphs, but he had other things to do as well, it seems. Sorry, Dijkstra, I don't know how to pronounce his first name, and it seems there is no Dutch guy in the room to help me out, so sorry guys. He said that saying that computers are thinking, it's like stating that submarines are swimming. Well, I'll let you digest a bit on that because it's too heavy for almost 6 o'clock. But, sorry, you cannot see everything, so I'll just try to mimic everything that's on the screen. Because we are taught these days that we don't have to think anymore. The generative AI is here for us. It's thinking for us, it's doing pretty much everything, except the laundry, but we're getting there. I just took that prompt, I dropped it in ChatGPT, and I said, please do something about these words and transform them into a picture, because English literature teaches us that a picture is worth 1,000 words, right? So it just took my scrappy quote, dropped it there, and put a lot of metadata and transformed it into a magic formula. And then they came back with this one. Well, I put it on my house wall, now I have art on it, and this is something that it just tried to transform into thinking and swimming. Well, I can say that it has imagination, but I'm old-fashioned. I already have white hair in my beard, so I went to as close as possible to a dictionary about generative AI. I went to MIT Education and I tried to figure out what generative AI is. And what I say is that it's that machine learning model that tries to mimic the data that it was built on. And it was built on, it was trained on everything. So it tries to mimic everything that it was taught. I don't know why, but for me, in my head now, I have the Chinese kiddies that you see somewhere in the windows, so it's probably a very tough copycat. But, well, let's give it credit. It does what it should do. And the interesting stuff that is happening lately is the fact that if we give it multimodality, meaning that we cannot work only on text, but we take text and images, interchange them, and then it's quite easy. More than just figuring out what is in the picture is not computer vision, but it just can take words, transform into something, and then they take them back. And I started with the movie. Well, I have two young children, and I try to find proper movies to make them think and dream about the future. So I took E.T., for example, and I just asked my fellow ChatGPT to tell me what's in the picture. And he just said, hey, are you dumb? Check it out. It's E.T. and Elliot just flying across the moon. It's a classic. But that wasn't enough for me. Hey, how about if you describe it a little bit more? And then he just dropped a huge chunk, you know, how it does the prompt and goes all the way with a lot of blah, blah, blahs. Well, I didn't put them here because it's obviously very interesting. And then I asked him, create the same picture. Well, pretty close, right? It's they changed the tree, changed the model of the bicycle, as you can see, and it put a backpack to be sure that it has all the books with it. And then I said, let's try different things to see how close can we do it. Obviously, it told me it's not possible. It's copyrighted. Right, you spend the last couple of years learning everything from the internet and you have a problem with the copyright. Great. Well, let's give it credit. It has humor as well. So, yeah, we did that, and then I just tried to do it. On the left-hand side, you can see the original, and then the takes of every one of the models. And the ones down are from the same model. It couldn't decide. It has so many ideas that it couldn't decide about what to do. So then you can see all the things that are going. And here probably is a depiction of if I continue using ChatGPT to do too many pictures, it's a depiction how probably the world will look like in a couple of months if I continue doing these things fast. So no water, no problems, right? And after that, my fellow Steve said, dude, you don't have the proper education. You should be a an astronaut because you're talking about planet B, so let's send you out in space. So he took my picture from university and he said, okay, let's try to do something with it. And then I just came back to be an astronaut, right? Then it asked me to turn right. Well, in the meantime, it started raining, so I put a helmet on my head. And it seems that after that, taking the helmet off, it shrank me, probably because of the dehydration, not enough water, I don't know. And coming to an end where it just looks exactly like me, well, maybe with a bit more hair and shaved, he said, okay, it's enough. Let's send you on a spaceship. And at least I look like, or I hope I look like Thor. I don't know the name of the Australian guy, but yeah, it's close enough. But what's the point of everything? The pictures are really to see the differences and how strange it behaves. But imagine that instead of pictures, it's your code. There are things that you don't necessarily fully understand, you don't fully grasp, because now we are encouraged to believe that we can do everything. We can do full stack, multiple stacks. We can build harder probably in the minds of our managers. So the thing is that it's very powerful. It takes a lot of things from point A to point B. It transforms things rapidly, it does a lot of modeling, it does a lot of mapping, but all those are glitchy. There are not two that are the same. And imagine now that it's code. It's code that is going to production. It's code that we are trying to use in a proper application. How do you know the difference? Because then, probably if you write it yourself, it will be easier. So just imagine that the pictures that you use are things that are incorporated in your application, jars, JS files, whatever. Or things that are really hard, they are compiled, you don't know what's in them. So how can we protect from those aspects? But of course, there are multiple beneficial aspects that we can use in terms of AI. I don't know about Portugal, I don't know about the rest of Europe, but I know in Romania, where I'm coming from, there is hard stuff to work with customer support, with medical stuff. Telemedicine took off during the pandemic. And now the problem is that the AI can do that for us, can make it easier. Just imagine, rather than listening to that awful music or just seeing the prompt and then forgetting about it, and then you just go back to the prompt and somebody told you that you're done, come back again. You have options, and those options can go across multiple industries. And you can just think about, for instance, I have problems picking up a lot of stuff in the retail industry. Just have a chat with a friendly bot. And the friendly bot will help you, and those are multiple things that you can think about. For instance, a project that I worked last year was for a legal company from the US that was trying to do legal tracking. So imagine things that are going a couple of years back, probably hundreds of years in terms of property, and it was doing everything automatically in a couple of minutes, then rather than having a person doing that for days in a row. So that's great. But there is something around it that is not exactly how you'd expect it to be. And sometimes, because obviously, I don't know, guys, I need your help now. It's the first time for me doing this, so how many of you did try a bot? And I need a raise of hand. Okay, great. How was your experience? Did you like it? Thank you. This was the first time for me doing a show of hands, so thank you for being together with me at this point. The thing is that what happens is that at points it gets a little bit tired, like us at this point. For instance, DPD is the company in UK where the chatbot decided to swear on the customer that was trying to get some things. Well, you know, the football clubs, the hooligans from UK, probably had a bad night. His favorite team lost, so now it had all the reasons to swear at the customer. So, yeah, we can understand that. Even worse than that, Air Canada was hoping that Sam Altman reached his final goal. And that means that AGI was here, and it's a sentient entity that knows what it's doing. Air Canada put a customer support that helped the customer by telling him to cancel his flight. And then he tried to, the lawyers of Air Canada decided to try to convince the judge that the AI is to blame. Well, we didn't hire the AI. He just goes rogue. We don't care about it. Unfortunately, they lost the trial. They paid some money. We are not there yet. And if you just think about stealing some things, doing some hacking tools, you have one in your pocket. If you have your Amazon application installed on your phone, you have a chatbot that will help you do malware. Well, just take out, rather than order food for your cat, just ask it nicely, obviously. We have to respect the almighty AI to give you everything that you need. And even if sometimes they tell you, okay, that's not possible, you can try different things. And researchers are trying, and one of the things that they managed to do is that they use ASCII art. Rather than using plain words, they use ASCII art to ask it, and then it just gave everything away. So we have to be inventive because there are multiple ways of going around it. And if that's not enough, there is more. If it doesn't go rogue, there is more. The guys on the other side, the hackers, you call them as you want, the malicious bodies that are trying to get the hand in your pocket, they are using it, and they don't need approvals, they don't need anything. Just a plain example is Black Mamba. Black Mamba is a script generated by ChatGPT by some researchers that decided to see how can they make polymorphic worm. So that meant that it was just shifting and changing shape and going around all the support and all the firewalls that we had in place, and it was extending and extending. And there are other examples as well. And then we have typo squatting, and that's a little bit easier. It just goes and just provides the information multiple times to ChatGPT up to the point where it believes that it really exists, and then it just guides you. Go there and download that dependencies. So everything just got a lot harder. I don't want to do politics, but we are in an election year, and deepfakes are the new norm. You can hear multiple things that are happening, and now it's plain and simple, just unbelievable. I remember a discussion that I had with a fellow friend when OpenAI Sora was launched. And he just said, he took his family, sat them on the couch, and he said, from this point on, you don't believe anything that you see on YouTube or anywhere else on social media, because pretty much everything might be fake. So that's the era where we are living in. But we are craftsmen, right? So we need to build stuff. And the AI is not only useful for building pictures and other stuff or poetry, but it can help us to take care of our chores, to just, this infinity from the DevSecOps space, and it can help in multiple spaces, from coding. That's probably the one that is the easiest way to think of it, but also from the requirements point of view, where you just take the requirements, you transform them, you augment them, and pretty much everything. Or just think about finding patterns into log files. And the examples can continue. It's just a matter of using your imagination. The LLMs are here to stay. Obviously, don't drop them in ChatGPT because, well, somebody will be upset about it, and probably that somebody is your boss. And these are a couple of things. Well, everybody's saying that there is no money in the software industry. There is, but everything goes to, you guessed it, generative AI. And there are tools like Tab9, Tabby, obviously GitHub Copilot, tools that you can use to augment your work, to make the things easier. Well, to be honest, now they made a step back, because initially what they said was that they are code generators. Now they took a step back and they call them code augmenters, because in the end, you're the one clicking and you're the one committing, so you're liable. Don't worry. Microsoft decided to help anybody that wants to use the Copilot if they have any kind of legal problems. And they said that they will pay for the fine and all the legal aspects if you will be sued. Well, I will not trust them, but you're courageous, you're here, so you might want to try that. Well, anyway, one of the nicest things that appeared lately and what's happening is that Cover Agent, was released. And that's an interesting aspect where you have the two facets of AI these days. On one hand side, you have the closed source, the open AI, the whatever you name it, Aleph Alpha or other stuff that are built in-house and the Google Gemini. And then you have the open source. The cover agent was built based on a paper released by Meta, former Facebook. And what they said is that here is the paper. Who wants to build it, they can build it. And now it's on GitHub for a couple of weeks now, the alpha version of it. And theoretically, it can help you build everything. And I like this thing because everybody said that, guys, you don't have a job anymore. Well, surprise, we have. And if you look at the scale of history, starting from the 1940s when computers started appearing, the number of developers grew and grew and grew with each iteration that promised that they'll send us on the beach side. And pretty much I was having a discussion last year with my former company where we were discussing about how should we name ourselves. We are currently on the dawn of a new era. How should we call ourselves? And they said, AI Software Development Company. Great. So before we implement AI, we should call ourselves IDE Software Company. Well, I don't think so. So that's why I don't think so that if we weren't scared about the IDE, it will take our jobs, we shouldn't be scared about that. Now you have to use your imagination because it's not that visible. So this is how the new LLM stack application looks like. It's again from the same company, from the company of brother Mark Anderson and Horowitz. And what they say is that this is the way how the new application would look like. The arrows, the red arrows, are coming out. It's output from the LLM. The blue arrows are going in, so input from the user. And then somewhere there, in the middle, one of the small boxes, it's the model. Everything else are additional stuff that we can use. And in the middle are orchestration software. And that's the Llama index, LangChain, glue code that you might want to write if you are good with Python. So this is how it looks like. And the reason why I'm saying is that because now, for me, it has two facets. On one hand side, we are users. We are using more sharper tools for our craft. But then we have to build this stuff. And I like to name them augmented channels, because up to now, what we did, it was scrolling. Well, yeah, maybe for Instagram, an infinite scroll that you scroll, you touched and you tapped, you interacted. But now, out of a sudden, we have another mechanism to use. We can call it ubiquitous interaction, zero UI if you want, because now you have a different way of interacting with your software, and that's the way how you do it. Just imagine the benefits of having this stuff. You work with a lot of software, you know how to use it, so now you can just ask the software to do what you want to do. But as you've seen, the complexity of it comes with a cost, and that cost is the attack surface. The attack surface is huge. There are multiple things that you didn't even think about before now. For instance, it's LLM prompt injection. You just come, you just make it to behave differently, as we've seen in the Amazon example earlier. Then imagine that you have this assistant that knows everything about you, knows the color of your eyes, knows what flower your wife likes, or I don't know, what football team your husband is cheering for, because you ask it to do everything for you. Order flowers, order cat food and everything else, and pretty much has all the information. And besides that, it's the only sieve through which we are going, and pretty much all the company has. So you can do like escalation of different sorts in terms of administrative rights. But the one that me personally I'm afraid of, and I don't know how to defend myself against, is model poisoning. Because in the end, a model is a mud ball of all the data that is built and built and built and dropped in a black box. And then, how can I know if something is hidden behind it? How can I know that something that I shouldn't be able to check is there? How? And that's the biggest question that I have, and currently there is no answer. Just think about, I don't know about you, but back in the day I was dreaming to be the Romanian 007. Well, it didn't happen as I'm here in front of you. And there were the sleeper agents. Those agents that were your colleague next to you, just watching the same presentation as you do, then at the point of a single word, the guy becomes a killer and just you can remain seated. Nobody seems dangerous here, but careful what you're saying. And that's the problem. It might be the case that the model has embedded in it a lot of stuff, and it behaves nicely in the training period, in the pre-training period, and everything else. And then, out of a sudden, it just has a word, and that's it. It just becomes exploitable, and it just creates all the exploitable code that you want. Just think about the XZ exploit that happened a couple of months ago, where somebody just build things over months, over years, and now out of the sudden we have all this stuff happening quicker and faster and in more places. Well, I know that a guy here in the room knows that we have a safety mechanism for it, but we'll leave that for tomorrow. Great. So it's thought that your software security chain is complex, right? We have these 8 boxes, and that means we pick a library, we code it, we test it, we deliver it, and blah, blah, blah. You know the drill, right? And usually we do it on Friday evening, so that we have a nice weekend. And now, out of a sudden, we have 5 more things that are probably as complex as all 8 of them together. Now we have to find out what happens with the AI, the training data, about the legal aspects. Yeah, and I like this line, so I have to say it. Maybe in Europe we don't innovate that much, but we regulate like hell. So yeah, the AI Act is coming, the Cyber Resilience Act is coming, the eIDAS 2 is coming, NIS 2 was released a couple of months back, sorry, and obviously GDPR, the pop-up legislation is there. So now we have a lot of other stuff, and guess what? It's there. This is an extract from the supply chain report that is done by Sonatype. Sonatype, it's not the one that is doing Sonar, but it's the one that has Maven Central. And pretty much, whether you're using Gradle or you're using Maven, your builds are pointing to it. So that's the source of truth for everything. And what they observed through last year is the fact that transformers, OpenAI, and other models are being used through LangChain in your application. And it's growing, and it's growing, and it seems that it's not going to stop, right? So, if you didn't like DevOps, and you didn't like DevSecOps, now we added 2 extra words to it. Now we have DevSecAIOps. Sorry, I'm still getting used to it, and I don't know if I should get used to it, because in a couple of days we'll have another word to it. So now what we need to do is that we have to think about unthinkable aspects. So probably the only thing for me that I can consider the best way to achieve it is to have smaller items that can be self-contained, because you need to have the blast radius contained around you. So let's prepare for the unexpected. And the biggest problem, as I mentioned earlier, is the fact that we have a black box. There are tools, I try to find other stuff, but for now, there is nothing that can help me do that, other than trying to build fences around it. So, what do you do when you pick a library, right? You have to implement something really cool, something that has all the approval of the product. What do you do? What do you do when you need to pick the new component that you build it? Well, probably this is the best thing that you can do. Finger in the air, and you'll understand all the things that are happening. You count the stars on there, and then you're just going and pick the model. There are close to 700,000 models open sourced on Hugging Face. Last time when I gave this presentation in April, there were 500,000. In the meantime, they increased. Well, it's not like the the GDP of the European Union, so it's growing fast. And the biggest problem is that the model is something, as you saw, if you remember the LLM stack earlier, it's something in a corner. And on top of it, there are other stuff. And usually, to interact with your application, you have the inference. And last week, I think, or 2 weeks ago, the Llama CPP, that's a small file that is open source on GitHub, had a critical vulnerability, 9.8 out of 10. Something was happening. When you're loading the model, the code was becoming exploitable. It was fixed, but you know, it's not that we are fixing the things quite fast. So what do we actually do? Because I tried to find other mechanisms, and then we'll see mechanisms that we can use for the Java side of our code, but I couldn't find any for now. And at this point, what we need to do, this is a tool, a set of tools actually. It's a canvas provided by Mitre Corporation. It's a company that I never heard of until I met some of its employees, and they are top-notch. It's a federal organization from the US government, and they are trying to make things stick for the defense industry in the United States. And they say something like, I want to have proper code if it's in the missile that will hit somebody. Well, I don't like their motto, but I like their work. And what from that side, I don't know, probably is the left-hand side of the slideshow, you can see how we can look at the way how you should think about your model. First, you do reconnaissance. You're just looking around like in a combat space. You're just looking for the things that might happen. Identify all the things that are in the public space about the model that you have. And then you start moving around on the access of the model, who has access to those points, escalation persistence, privilege escalations, discovery, attack of the ML stack, signing, and so on and so forth. And then there is OWASP. We all did some JavaScript side, so we all know about a couple of things that are happening there. OWASP just built the OWASP 10 LLM problems that might appear. And among those things are things like model poisoning, prompt injection, privilege escalation, and some other stuff that I'll not go, model theft, and so on and so forth. Unfortunately, for now, there is no tool that we can use. They just tell us, so unfortunately, we need to do governance. And that's not something that we want to do, but we have to. Google has a big chunk of it and has 6 steps, and what they call it, they develop the so-called secure AI framework that provides all the hints how to incorporate those aspects into your daily routines, how to extend it to the AI space, and so on and so forth. But the problem is that a lot of the innovation and a lot of the trials that we did were through APIs, through tools like OpenAI that were in the cloud, because it was harder to just start it on your machine. And in March, in spring this year, during the Kubernetes conference in Paris, Cloud Native and AI declared love. On the left-hand side, representative of the AI space were the manager of Google Generative AI from, the representative of Gen AI from Google, Paige Bailey, the CTO of Mistral. He's French, so I cannot pronounce his name, I'm sorry. And then there was the guy that made Olama. And what they said is that they want and truly believe that AI and everything else, all the innovation that is coming around it, should be open source. And that's why they asked the broad community of Cloud Native to help them out, because they believe that Kubernetes and Cloud Native are able to help out with the workloads that are in this space. Well, the previous week, Mistral signed with Microsoft, and they just kicked the open source concept away. But, well, anyway, we have to believe them, right? And during the same moment, what they did, they open sourced, or they published, the reference architecture of the Cloud Native AI application, LLM stack. And what they do is that they are building this stack, starting from here, at the hardware level, and they are moving up. Here, where you have all the PUs that you can imagine, TPUs, GPUs, CPUs, or whatever, where you have hardware engineers in terms of personas, then moving back in the terms of infrastructure and how you build it, whether it's a cloud provider or it's on-prem, then you move to the platform space because everything now should be a platform, and then moving slowly up to the point where you have the workloads, where the applications are living. And there, you can be a chat, it can be a RAG, it can be a predictive model, a discriminative model, you name it. And here, probably you heard a lot of things like security shifting left. Well, I heard that also data is shifting left, governance is shifting left, and everything else is shifting left, so a lot of other things are happening in the space, so it's not that we should be afraid of what's happening. But as we ended up on the top level, the part with the workloads, that's the place where probably most of us execute. Because I would suppose that we are developers that are building applications. And those applications are built around 90% out of open source projects. And we take it for granted, unfortunately. And that's about to happen. What's about to happen is that we'll see what comes next. Because now the attacks are not that simple as they used to be. We are not looking only at 0 days, but we are looking at supply chain attacks. Attacks that are very complex. And you can see there that 250,000 attacks happened in the previous year, 2023. Well, it's not that much. There are other things that are happening worse. But the problem is that is twice as many as the previous 2 years, actually the previous 3 years before that. So it's growing, and it's growing rapidly, exponentially, maybe. So what can you do? About the models, I'm sorry, there is nothing that I can share with you that we can do it, other than all the points that we have to do and put in place. But we have to take the finger from the air and put it on the mouse or keyboard or whatever you want, and we can use this new methodology or framework, if you want, to use the next jar, the next library that you use. And that one is the OpenSSF, Open Software Security Foundation. And what this thing is saying is that there are 5 edges that we have to look into. Testability, the build process, vulnerabilities that are implemented there, risk assessment, and all these things have multiple points. And luckily for us, it's not a checklist. There is also an application that you can use and just target it to your GitHub repository, and it will just look into that and come back with a score. Simple, up to 10 points, and tell you whether the library that you want to use, it's something that you would like to use or not. For now, these are the 4 libraries that I used and I tried in the Java ecosystem. And those are LangChain4j, that is the cousin in the Java space of the probably most popular library out there, LangChain. There is the version of Quarkus implemented based on LangChain by Red Hat, and it's open source. Then we have Spring AI. Well, Spring is built in their ecosystem. It got inspired from all the other ones, but they built their own solution. And last but not least is JLlama. JLlama is a library that was implemented and is available also in Maven Central and also in GitHub if you want to see the code and fork it. And the interesting part of it is that it's built on top of the new Vector API and the Panama project. So most of the load is done through Vector API, and at the point where it cannot do the heavy lifting, it just bounces back on the Panama project in the native space. And as you can see, I took each and every one of them and looked through them. And what happens is with the LangChain4j, it has around 4,000 stars, so it's not really relevant about in terms of quality and what happens on the other side in terms of security. And they have a bunch of problems because they don't do code review, they don't have protected branches and other stuff, but they are trying. After that, if we look at the other ones, this one actually decreased in terms of, they improved in terms of quality. Quarkus is doing a great job. I like it particularly very much personally because it has that feeling of declarative and the mixture of fluid APIs. But the problem is that it's focused on the Quarkus ecosystem, so probably you have to do two things at once. Move to the Quarkus ecosystem and then implement LLM. But then we can discuss how you can convince your manager, because that's the top question that comes when you're discussing these kind of changes, right? Then we have Spring AI. Again, this is pretty much similar to all the other stuff that is happening in the Spring ecosystem, but what's surprising for me is that all of these projects that are very essential to what we're building, they are very low in terms of content. So I don't know what's the system in Portugal, but in Romania, a 5 means that you're barely above, under the line in terms of exams, and you're not the best in school if you're doing that. And JLama, last but not least, for a project that is maintained only by one person, it has quite an impressive outcome, and there is more to come. I encourage you to use them and see how the things are going, because they use oh great, I don't believe you see anything, so I'll just try to mimic this stuff. Well, before you try to just build stuff and put it in your code, there are other ways of doing it. Olama wants to be the Docker of LLM models. So you just install it, it's simple, it goes quite quickly on any of the 3 major operating systems. And you can just play with everything in terms of prompting. Then Postman, they just released a couple of weeks back a new extension that is focused on the AI space. What they're trying to do is to help you make the step between your local environment. Well, it obviously works on our machine, so now you have to push it to the cloud, and Podman promised to do that for you. JLama has also a small application that is helping you to push the things forward. And last but not least is Genie, created by the folks from DevOps. That what I particularly like about it is the fact that you can use multiple models in the same time and compare the results, test it. So you ask a question and you see how Llama 3 is responding in comparison with Mistral and with other stuff. And that gives you a nice graph to allow you to do quick iterations in terms of proof of concept without even writing a line of hello world. But obviously, our preferred response is, it depends. Yeah, we know, we stop here, it's all clear what we have to say. And I had to put this on the slide, because everybody's saying that, right? English is the best programming language. Well, take it with a pinch of salt, with a lot of salt actually, because it's not like literature. It's not like, you get it. It's not like literature, because it's a lot harder than it might seem, and there is a lot of things to be built up to the point where we can say those aspects. And just to close in terms of what we need to do is use code augmenters, use code generators, use whatever you want, but use them like doing pair programming. Generate the tests, write the code. And the other way around, don't trust them. Keep the human in the loop, because you need to understand all these things that are happening. The other interesting aspect is that the risk of LLMs is the fact that we are being exposed through them to social engineering, but also to software practices that you usually have problematic in terms of security. And be careful. That's one of the biggest ways, the most important ways of protecting yourself is testing the outcomes. Just put tests on top of it. Make sure that the outcome that you're expecting is there and is the one that you actually want it to be. Thank you. Yeah. If there are any questions, please, now is the moment, or let's go to the party. Okay, I hope I managed to put you to sleep. I saw a couple of guys yawning, so my thing is done. Thank you.